that part of in SQL where we've started working with more than one table, right? So we have more than one table in the database. And definitely if we have to retrieve information and that information is distributed amongst these tables, then I have to join those tables. I've already talked about why we need more than one table in a database. Logically, I mean, you don't put all information about all entities in a single table for an organization or an application and say, oh, everything is there. That can't happen. So we have to have different tables. On top of that, we also have to follow some rules, or they're called normalization forms. And I had talked about the first normal form, the second, and not yet third, but first and second. And what I've also done is, I don't know how, I don't think you may have even noticed it. I've put up a normalization.zip file on Blackboard. I won't have time to do normalization with you. I don't think so. I will have it. So I've put an example there where I have said, oh, this is the first, this is not in the first normal form. Now it is in the first normal form. This is not in the second normal form. It is in the second normal form now. So when I do my examples, I'll talk about them. I've already, so the definitions are there, right? So I'll repeat those definitions for you quickly, but normalization.zip under your weekly learning gives you some examples of tables that are not in a particular normal form and then how I've converted them into their normal form. So these are rules. You have first normal form, which is the minimum. You have to have all tables in the first normal form, which means every table must have a primary key and there should be no repeating groups of data in a field. Or in other words, it's also said that every field must be atomic in nature. You can't break it down. Okay. Again, can't break it down or need not break it down is what you have to keep in mind. So that's the first normal form. The second normal form says, a particular table is in the second normal form if it is in the first normal form. So it has to be in the first normal form, and every non-key field, that means every field that is not a part of the key, has to be fully dependent upon the key. It can be partially dependent. So therefore, the second normal form only you only have to look at a table and say, does it have a composite primary key? Does it have a primary key which is made up of more than one field? If yes, then you look. Every other field that does not take part in the primary key is fully dependent upon the whole key, not partially dependent upon it. Otherwise, we'll have to change the structure of the table. That means we'll have to break up the table, right? So if I come across any table here, I'm just doing my first example. I'll show you, and I've said they're all in the first normal form. We already talked about it. None of these tables have a composite primary key. A composite primary key means more than one fields together make a primary key. So when there is no composite primary key, it's automatically also in the second normal form, right? So every table only has one single field. So here only the job ID. Here only the contact ID is the primary key. But again, if job desired, if I said, oh, a person can desire more than one jobs, then contact ID will not act as a primary key. Then something like contact ID and title can together act as a primary key. So this person wants to be a web programmer. The same person also wants to be a database programmer. The same person is also okay with being an application programmer. Then of course, contact ID cannot become the primary key, because remember, every primary key must be unique in nature. So in that case, if your key is composite, is made up of more than one fields, then comes the question of, oh, every other key, is it dependent together on the whole key? So for a minute, let's assume that a person can have more than one job desired, which is nothing wrong, right? You could have more than one job preferences. So in that case, can contact ID be the primary key? No. Why? Because maybe 7 wants to be a computer programmer, but 7 also wants to be, say, somebody like, I don't know, we can just take a web programmer. So if I repeat this record and I say web programmer, now this cannot be the primary key because 7 is not unique, right? So in that case, what do you think can act as a primary key? So suppose a person desires more than one job. Now, if that's the case, then what do you think can be the primary key of this table? Think about it. What combination? Contact ID alone cannot be the primary, because 7 is not unique, for example. A person can desire more than one job. What combination here can be the primary key? The most logical combination that can be the primary key. Think about it. What do you think? Which fields together can make a primary key of this table? And the title? That is unique, right? I won't say 7 wants to be a computer programmer, and again, I won't say 7 wants to be a computer programmer. So how will I say it's a primary key? There are two ways. You can put the word primary key right in front of it, like here. So now you'll say, oh, can a table have two primary keys? It doesn't have two primary keys. You are saying the combination is the primary key. Does it make sense why this should be the primary key? Why? Because this combination uniquely identifies a record. It is unique in every record. It can't duplicate. So if Anju wants to be a computer programmer, so my contact ID is say one, and my title will be computer programmer. If I want to be a web programmer, I'll say 1, web programmer. I won't repeat 1, computer programmer again. Now this is a composite primary. So you put the word primary key in front of all those fields that together make the primary. That's one way of doing it. And the other option is, which we've done before, but you can again, just so that you know, the other option is you can also do it this way. You can write the word primary key here and write these two fields inside it. That's another way of doing it. Both these are allowed. Yes.
So when you describe the table, will it show the 5 fields plus a 6th field for the combination?
No, it won't show. I'll show you the structure. All it will do is it will put the primary key symbol in front of the two fields. There's no new field at all. The table still has 1, 2, 3, 4, 5 fields, right? But the combination of contact ID and title is now the primary. That's all. So a table can have a composite primary. It's allowed. These are not two primary keys. The combination is a primary. Every table can only have one primary, nothing else. If I do this, now I'll be okay with the 7. If I did not have this, see, try it. It's not a big deal. Let me show it to you. Let me comment this out and let me comment this out. So your table only has contact ID as your primary key. Let me only run this program till here. What do you expect? 7 is repeated. Oh, now I'm not connected. Okay, of all the things to do here, I don't see a connection. Oh, I know why, because I shut it down. So there is no connection, so I can't run it. So let's try this very quickly and I should be okay to go. And then start with the workbench. Red, orange, green, come on. There. And there, okay. Let me open my workbench. Let me open this comp. And hopefully, so job desired. Okay, so it only has contact ID as primary key, but there is a problem here. See, 7 and 7. There are two people with the primary key. So I'm going to run it only till here. And I'm going to get an error. And my error will be there. Do you see the error? It says duplicate entry key 7 for primary. Makes sense, right? You said contact ID was my primary key. That's what you said. But here in the table, you put 2 records with the same primary key of 7. This cannot happen. A primary key has to be unique and not null. And this cannot happen. So now what do? I need, a person can desire more than one jobs. I need to put this information that person 7 wants to be either a computer programmer or a web programmer. I don't want to combine both those fields together. Remember, otherwise it won't be even the first normal form. You say, why don't you keep all your job design in one field? I mean, why don't you just say title computer programmer, comma, web programmer, comma, whatever? We can't do that because no repeating data in a field. First normal form says no repeating data in a field. I can't even do that. So what will I do? Then I can think of this. I'll say, okay, instead of just putting contact ID as the primary key, I'll make the combination as the primary key. So let's try that. Now the combination is the primary key. Now run it again, only till here again. Now it won't complain. Why? Because 7 plus computer programmer is different from 7 plus web programmer. And I shouldn't have any. It is slow today. Unless I made an error. Yes, I have an error. Multiple primary key defined. Oh, oops. Okay. I see what it is saying. It says you can make two keys. You can't have two primary keys. So definitely my problem is here. This is my format and this is not my format. Okay, so let's remove it from here. And let's remove it from here. SQL doesn't allow you to put primary in front of 2. You have to put it this way. Now let's try it again. So you have to put it this way when it is combined, okay? And let's try it again. It's happy now. No errors. So now what have I done? I have made a composite primary key. I have a composite primary key. And this is how you define a composite primary key. Composite means consists of more than one fields. All you do is you say primary key and all the fields together that make the primary key, you list them. So here is an example. Now let us see, is this in the second normal form? Okay, now the question, is it in the first normal form? Yes, it has a primary key. Yes. Is every field atomic in nature? Yes. So it is in the first normal form. Is it in the second normal form? Now, what are the non-key fields? These 3 keys are non-key fields, right? These 3 fields are non-key fields. Now, let's look at one field at a time. Is salary low dependent upon the competition? Of course, Anju wants to be a computer programmer and is ready to take this as salary. It's not dependent upon a part of the primary key. Is it only dependent upon contact ID? No. It is dependent upon what kind of job does this person need. So it is fully dependent upon the primary key. Let's look at salary. Same concept. Years of experience. Is it only dependent upon contact ID? No, it depends upon how many years did I do computer programming, and on the other hand, how many years of experience do I have in web. So it is again fully dependent upon the primary key. Now, if for whatever reason the years of experience were just total years of experience, it only dependent upon the person, then I would have to remove this field years experience from here. I cannot keep it in this field. Why? Because it is only partially dependent upon the contact ID. It's only partially dependent upon the primary key. I couldn't add. I'll have to remove it. You'll say, then what do you do? Where do you keep this information? I'll have to create another table with contact ID and years of experience, or I can add the years of experience to my first table, my contacts. That's total years of experience. Doesn't matter where you took it. Whether you did Tim Hortons, whether you did it in Georgian College, whether you worked with BMO, or whether you worked wherever. Years of experience means years of experience. Here, this years of experience is kind of linked to what job do I desire. So if I want to be a computer programmer, how many years of experience have I had in that field? If I want to be a chef, how many years of experience did I have in that field? So if I was a chef when I was young, right, and now I want to be a computer programmer, the chef experience doesn't count in a sense with my computer programming. You could argue, oh, it gives you whatever, but it doesn't, right? They're two different professions altogether. So again, years of experience is totally dependent upon the combination. So this table is also in the second one, right? So the second normal form says the table must be in the first normal form, which it is, and every non-key attribute. So if you want, I can put it here. I've already given this information on Blackboard. So this table is in second normal form because it is in first normal form. We already know the definition of first normal form. If you don't, let me write it for you. Let me write it for you so that you have it. This table is in first normal form because it has a primary key. We call it PK, right? And every field is atomic in nature. We also say, in other words, we also say no field has repeating data. No single field has repeating data or repeating group of data, whatever makes sense to you. Right? And a good example of repeating data was your favorite sites. The first one we did. Favorite sites is an example of a field which is repeating data. Site number 1, comma, site number 2, comma, site number 3. It's repeating. The same kind of data is repeating. So that shouldn't be there. So look at this table. Does it have a primary key? Yes. Is every field atomic in nature? Can you break up any of these fields further? Can you break up last name? No. Can you break up first name? No. They're all atomic. It has a single value. Atomic means single value. Phone, you'll say, oh, you could argue about it. Maybe it's the home phone. It's a work phone. It's a cell phone. If I wanted to keep all that information, then you won't have a field. Then you would have work phone, you would have home phone, and then you would have cell phone, mobile, right? Then I would have 3 fields. I wouldn't keep it in one field. I cannot. I cannot keep more than one repeating data in a field. Otherwise, it's not in the first normal form. These are design issues. Very important. If you don't design your tables well, at the end of the day, your database will fall down someday for sure. Okay. So I've said this table is in first normal form because it has a primary key and every field is atomic in nature. That means no field has repeating data. Okay. That's what a first normal form is. So you have it, and I'll put this on Blackboard. That way you know. Let's look at another table. What about job current? Is it in the first normal form? Yes. Does it have a primary key? Yes. Is every field atomic in nature? Yes. So this table is in first normal form. This table is also okay. It is in the first normal form. So we should have all tables in the first normal form, and now we know about the second normal form also in the second form. There's a whole list. First normal form, second normal form, third normal form, fourth normal form, fifth normal form, BCNF, boys squad normal. There is no end to it. The better up the hierarchy you are, the better design tables you have. So first normal form is the minimum requirement, like the least requirement. So that's, you should always have it. So we've gone from 1, and I just, for the heck of it, I created a second normal form also for you, for job desired. What did I do? I created a primary composite field, right? So this table is in the second normal form because it is in the first normal form, and every non-key field. What does that mean? Any field that is not taking part in the primary key is fully dependent on the composite. Composite means combined PK. That's what a second normal form is. Make sense? So it is in the first normal form because every field, it has a primary key. Yes. Every field is atomic in nature. Yes. So it is in the first normal form. And every non-key field, that is salary low, salary high, years of experience. These are the 3 fields that don't take part in the primary key, are fully dependent on the composite key, not on part of it. Not on part of it. That's what a second normal form is. That's what I mean by second normal form. So here, the combination of contact ID and title, and how do you show? How do you show it? Line number 98 shows. Line number 98 says, my primary key is the combination of contact ID and title ID. That's what it is saying. The foreign key is simply saying that this contact ID must draw its value from the other table, right? And now I can have this. I can do this. I can have this combination. 7 wants to be a computer programmer also, and 7 wants to be a web programmer also. Which is logical. There's nothing wrong in it. People can desire more than one jobs, right? A person can want more than one jobs. So just because I wanted to show it to you, I've changed my table structure. Right? You can keep the old one if you want, and nothing will change, but this was a good example where I could do it. And it was very logical also, because a person can desire more than one job. A person, then you can argue a person can have more than one current job also. Yeah, yes, here it is. You could have a full-time job, you could have a part-time job. You could do that too. But I'll stick to this one. I mean, otherwise I'll have to change it every day. But if that was the case, what do you think I'll have to do? You'll have to go to your job current table and you'll have to change it. You'll have to change this too. What will you do? You will say contact ID and title, salary and start date. You can make the combination, and then you can't only work with contact ID. You'll have to have the combination. That is, a person can be a computer programmer, and then a person can work also at a model engineer. You know what I mean? That's also a job, right? So you'll have to change this table also. So if a person can have more than one current jobs, then here you'll have to change this table, or you do the same thing. You add a new primary key and make the combination contact ID and title as the combination. Is salary dependent upon the combination? Yes. Anju earns this much at Georgian College, Anju earns this much at Tim Horton, and start date. Yes. I mean, when I started at George, it has nothing to do when I started at Tim Horton. They're two different things. Yes.
So when we have a composite primary key or trying small tables, that is right now like the foreign key.
So the foreign key has nothing to do with the primary key.
No.
No. Now, because look at this table. The only thing that is important in this table is that the contact ID must draw its value from my contact. Now, if you had a table of titles and you said my title should also draw a value from there, then we'll add another foreign key constant. We'll add another key. But title, I haven't created a table. But if you say, oh, these titles are valid, otherwise maybe people can put a title like hello. You know what I mean? So if you say, oh, this is an organization that only works, we only hire people in the computer field, then you could create a table called title and title ID, and then you could say my title is drawing its value from the title. But otherwise it doesn't affect it. No? Right now it doesn't affect it. And it doesn't. Look at job desired. Has job desired table changed in any way? No. All that I changed was line number 98. Did I change the definition of my foreign key? No. My foreign key contact ID, I still have only a foreign key and it draws its value from the table my contacts. But you can add as many foreign keys as you like in the table. Nothing stops you. Your title could be coming from a title. That's another, I mean, not very valid, but then it could be, oh, these are the valid titles in our country. You know what I mean? You could do that. So any number of foreign keys can exist in a table, but only one primary key can exist in the table. That primary key can either be a single field or it can be a composite, combined field. And you will have to make it. There is no other way. How else will you, if I don't make title as a primary key, if I remove it, then I'm lost. How will I put in information about a contact who wants 2 different jobs? How will I do it? And it's quite logical that it can happen. You can desire to be more than one, be in more than one profession. So there's nothing wrong saying, oh, I want to be a computer programmer, or I also am okay with the web programmer. So it's very logical, right? So you'll have to change the structure of your table, and that's how you do it. You change it, you just change it. You say, oh, the combination is now the primary key, so I'm okay with this. Nothing else changes. Okay, so I'll leave it here because it's a good example where you can do it. The job listings has nothing to do with the other tables at all. Nothing. It has no relationship as per se. It just says, oh, these are the jobs in the market. So it has no, it just has a primary key. It has no foreign keys at all. And then we were working on some queries. We had completed one, I think for sure, where I said, show me the name and the phone number of all those contacts who are interested in a computer programmer job and are ready to accept a salary. So we had written it in various ways. And then I'd also given a subquery for it. And now we'll start doing this. So that's our job now for today and Monday. Learning to write joins and subqueries. And therefore, I've given you an extra day for your assignment to wrap it up. So after today's class, most probably you'll be able to do your assignment. But you just want to be sure that I've covered everything. And I want to be sure that an assignment, I've told you everything. So therefore, after Monday, I've given you till Tuesday midnight to submit it. Just to polish it at the end. So keep working on it. You can. After today's class, I think you can almost do 90% of it. One question, maybe something you may not be able to do. And it depends. Maybe I can cover it today. Okay, let's go to the next question. It says, select the full name and phone of all those who are looking for a job. So which people are looking for a job? I want their names and phone numbers. So remember what I told you last time? Always, it's a good thing. I mean, you don't have to, but it's a good thing that you create a, I think we've run the script once for sure. I'll just kind of run it once again. I did part of it. I'll just run the whole thing now. So all my tables are created. 4 tables are created. Everything looks fine. Yes. Now let's go to database, reverse engineer it. Go to my next. Say I want to create a ERD, entity relationship diagram for my DB jobs database. And there it is. So remember, what does it do? This table will kind of give you the relationships, the fields, everything you can see in one go. So it's easy. And you have this in your assignments also. You have to make and give me a hard copy of, of this diagram. Most of you will just kind of copy and paste, but you need to explain to me what does 1 mean, what does that infinity sign mean. So I've said label it as 1 to m, m for many, infinity means many. So I've said label them 1 to 1, 1 to many to many. These are the relationships that can exist between two fields. So you can have a 1-to-1 relationship, right? You can have 1-to-many relationships. So for example, if Georgian says a student can only take a program in the college. So there is a 1-to-1 relationship between student and program in the college. Georgian college says a student can take more than one programs. Then the relationship becomes 1-to-many. One student can take COPA, the same student can enroll in another program, hospitality, the same student can enroll in another program, I don't know, whatever, right? So that's a 1-to-many relationship. And then many-to-many means it's a relationship, a good example at Georgian College, many-to-many teachers. Anju teaches many courses, but the relational database course is taught by other teachers also. So I teach a section, another teacher teaches a section, and so on. So so that's a many-to-many relationship between courses and teachers. A course is taught by many teachers, and a teacher teaches many courses. That's a many-to-many relationship, right? So these three kind of relationships can exist between tables: 1-to-1, 1-to-many, many-to-many. Those are the only three type of relationships that can exist. And I've just given you logical examples of each. A student can only take a program at the college, 1-to-1. A student can take any number of programs at the college, 1-to-many. And the relationship between teachers teaching courses is a many-to-many. Anju teaches many courses, and a course that Anju teaches, for example, relational database, I'm teaching it, and I'm sure there are other people also teaching it, because we have 5 sections of the same course, right? And I only teach one section. That's a many-to-many relationship. So 1 is given by the number 1, and many is shown by m. Okay, that's what I've asked you in the assignment. Please label it 1 to m, m to m, or whatever the relationship is. So it's not a tough one to make. You have this help. You have help. You can do a reverse engineer of the tables, and then all you have to do is you can make even a printed copy and then just change the infinity to m of it, and then tell me what they are. So I need you to explain it to me. Don't assume that I know that the key sign there is a primary. I have no clue. Don't assume that that red primary key says it's a primary key also and it's a foreign key also. So you have to kind of make a legend for me at the bottom of the diagram. And you should know too. So look at it. Do you notice a change that has come in my table? Notice this contact ID and title are both have a key in front of it. Notice this diagram has changed from last week. I have a key symbol in front of both the fields. That means it is a composite primary key. But why is one of them red? Because it is a primary key also, and it is also a foreign. So anything in red says primary and foreign. Anything only in yellow says I am a primary. Okay, so you should give me a legend and say, tell me what each one is. The blue one also has a significance. I can't recollect it. See, notice there's a blue here, and then there is a empty blue here. I think it has to do with null and not null, if I'm not mistaken. Let me double check. I'm almost positive, but I could be wrong. It's been a while since I've used these diagrams. Let's see, is phone or are all the fields null and not null? See, yep. Notice the difference? Any field that is not null has a blue filled diagonal. And any field, zip and phone, can be null. They have a diamond, but only an outline. It is not filled. So again, from the diagram, you can kind of not guess. You can make educated guesses. So notice the phone and the zip have only the borders. It's a diamond, but only a border. The other fields are colored. And what are they? Colored ones means they are not null, and the empty one means they can be null. And this is not the only software available to make ERDs. There are many softwares out there. You can do it by hand using a pencil and an eraser and a paper. You can use any software that you are familiar with. This is one of them, of course. But of course, I want to know what each symbol means, because I don't know. I have no clue that the key is a primary key. So you can color it if you like, or you can just use a symbol and make a legend for me. I need to know what they mean. Otherwise, it's 1. And again, infinity, you can replace this infinity sign with M for many. Similarly, replace this infinity sign with M. So that's what I've required as a hard copy, because that's what I want from you. You can give me that hard copy on your last day of classes on Friday. No big deal.
So if we're making a legend for the symbols in the data of these tables that are showing up, can we not put like part of the legend and say like M equals the infinity symbol?
Sure, if you want to.
Okay.
Yeah. No, that's okay. Usually the infinity symbol is not used at all in ERDs. Only this is drawn here. It's always 1 M, 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 or 1. That's why I want you to use M, because you will never see the infinity symbol. You'll always see the M symbol. I don't know why they put it, but I mean, I can change that software. But notice how here they've done it: 1 to 1, 1 to N, 1 to 1, 1 to N, N to M, and 1 to N. They've never used infinity if you draw it yourself. Right? They've never used infinity if you draw the diagram yourself. But when it draws it, it puts 1 to infinity. I mean, infinity means many. We know that. The only difference is we don't know how many. So, but notice when you draw it yourself, they have those 1 to N, 1 to N symbols. So they never do it. So you can, if you like, put it in the legend, but you should know that infinity means many. Okay. Okay. So here is my diagram, and now it will help me to answer my queries. So it's always a good idea to keep diagrams. I mean, I've used it. I've done this a couple of times, so it's in my head, but otherwise you will need it. Okay. So now it says, select the name and the phone number. So where is that coming from? From this table, name and phone number, right? So name and phone number are coming from here. Of all those who are looking for a job. So where is that information? Looking for a job. So which 2 tables do I need to join? These 2 tables. How can you join these tables? What is the common field in them? It's called contact ID here, and it's also called contact ID here. So when I join, I'll have to join on equality of these fields. Okay, so it's basically saying, okay, everybody who is wearing a hat says hello to every other person who's wearing a hat. Only then can you join. Again, join conditions can be equal, unequal, greater than, less than, it could be anything. But here, I want to find out who's looking for a job. So definitely I needed equality. So Anju is looking for a job. Pick up the contact ID from here. See, is she looking for a job? Yes, she is looking for a job. Spit it out. What's her name and what's her phone number? Right? Okay, so let's try. So we need 2 tables. So again, you can do it in many ways. I mean, you can use the word natural join, you can use inner join, you can use where, you can use on, you can use using, you can use comma. Those are just different ways of writing the answer using inner join. You can use outer join also if you like, and left outer join or right outer join. So I won't go in each one of them, but I'll show you one example of inner join and one example of outer join. Okay, so let's do it. Okay, so select the full name. So full name was not a big deal. We'll select it from here. And the phone number. So using joins first. Okay, which 2 tables do you have to join? We just kind of made these are the 2 tables we want to join. We want to join the table my contacts. You can use the word inner join if you like. You can use comma if you like. Whatever makes sense to you. You can give it a name if you like, as MC, my contacts. You can use comma, and the other table that I want to join is TBL. And it was called job desired. There it is. Let's call it job desired. JB. JD for job desired. Again, the word as is optional. And again, you don't mix and match in your assignment, guys. My aim is to show you how you can do it. When you write it, please be consistent. Okay. Now, what is the condition? What is your join condition? The join condition is, so if I'm using a comma, I'll have to use a where. I can't use on. What is your join condition? Your join condition is that MC's contact ID should be equal to JD's contact ID. So do not ever forget your join condition. If you forget the join condition, remember what will you have? A Cartesian product of the 2 tables. Everybody says hello to everyone. If you forget your join condition, your answer will be completely wrong. So this is very important. Don't forget your wheres or your ons, whatever you're using. Okay, now, So I've said, okay, I want the full name and the phone of all those people who are looking for a job. And there it is. Job done. These are people who are looking for a job. Right? That's it. That should give me the answer. So let's see. The guy 7 was looking for a job, remember? Because we just did 7 twice. I remember because we just did it. 8 is looking for a job. 4 is looking for a job. 10 is looking for, these are their job desired. What jobs do they desire? That was the question, right? It says looking for a job as listed in job desired. So job desired is I'm looking for this job. So I should have 1, 2, 3, 4, 5, 6 people. 6 answers. Let's run it. I can only run the last one. That's the only new one I wrote. And you will notice something. Since 7 is looking for 2 jobs, his information will come twice in the table. And who's 7? I am assuming Renee is 7 because her information is coming twice in the table. So why is it coming twice? Because this person wanted to be a programmer, a computer programmer also, and a web programmer also. Now, if I don't want to see this double, what do I do? Do you remember? If I only want to see the information once, what do I say? I just put distinct in front of it. I'll only see the information once. So is it wrong to show information twice? It's not wrong, but why will you see the same information twice? Like I don't want, I mean, all I'm interested in is who is looking for a job. That's all. So why will you say, oh, Renee is looking 2 times for a job, right? So select the full name and the phone of all those who are looking for a job. That's your join. So again, you can replace your comma by the word inner join, not a big deal. So whatever you like, all you have to do is replace the word. Excuse me. This is another way you can do it. This is the third way you can do it. And this is the 4th way you can do it. These are all inner joins. All of these are examples of inner joins. Remember, instead of the word inner, without giving a condition, you can say natural join. And this is by default an inner join on equality. So there is a joining condition inside it automatically. You'll say, oh, you just said don't forget your condition, but you haven't given a condition. But a natural join is an inner join with equality on the same named field. Don't forget, the fields have to be named the same. Both fields are called contact ID, and I'm doing it on equality. So I can use this also. Which one does Anju like? They're all the same. It's your preference. Unless I say use natural join or use the word inner join. No preference. Do whatever you like. Any of these 4 answers are right. And they're all inner joins. They're all examples of inner joins. One with the comma, one with on, one with where, one with the word natural join. But you have to be careful. You can only use natural join if the fields have the same name and you want the condition of equality. Otherwise, you cannot do it. But that's what I want. Are the fields named the same? Yes. Contact ID and contact ID. Am I looking for equality? Yes. So I can do it. If their name were different, or if instead of equal, it was something else, not equal, greater than, less than, then I cannot use natural join. Okay. Now try using an outer join. You remember what was an outer join? You have a left and a right. The only difference is which is the major table. So what should I do? I should pick up a record from the job desired. Oh, 7 is looking for a job. And all I want to know is what's your name and what's your phone number. So which table do you think I should make my master table? Which table is the table that I'm interested in? Is my contacts my master table, or is job desired my master table? Which of the 2 tables is where the information is? Who is looking for a job? Which of these? Job desired. Definitely, because that's the table which has the information. Who wants a job? Right? So let's try doing that now using an outer join. So let's take this again. Let's use an outer join now. And again, logically, you could say, oh, I'll use either of the tables. It doesn't matter. But I'll think a little. I'll say, oh, because this table is what is the kind of the important table or the table that will do less work, I'll make it a right outer join. Because this table is my kind of master table. These are people who are looking for a job. Why will I do the other way? Why will I make, I mean, it will work too. It will just take more time. I could have thousands of contacts, but maybe only 20 are looking for a job. So the smaller table is where I want to kind of look for, not necessarily smaller, but logically, who is looking for a job? That information is in job desired. So what am I saying? Pick up one record of this table and find its partner here and give me the name and their phone number. But if you remember what happens in an outer join, let's see what happens. Instead of this, I'll just give a star for a minute, just because outer joins are a little finicky, not finicky, a little tough. So I've connected it. So I'll only run this one. So everybody will find a partner. Why? Because contact ID is a foreign key. The contact ID in the job desired is a foreign key. It cannot exist if it is not in the my contacts. It can only exist if it isn't. So what happens? 7 says hello to the 7. So 4 says hello to the 4 there. 7 says hello to the 7 there. 7 will again say a hello because 7 wants 2 jobs. 8 will say hello, 9 will say hello, 10 will say hello. Of this, I'm only interested in the first name and the last name, and I'm only interested in their phone numbers. That's it. So always when you do an outer join, I would recommend that try doing it with the star so that you know, you can see all the fields. Oh, everything is working properly. And then once you are satisfied, I have to pick up all my records. I don't need any other condition. Just now remove it and now try it. So the information is all right. Do I need any extra condition where it is null, not null? No, nothing. There it is. I can change the same into a left outer join, but see the difference. What will happen? You will say, why did you use this as to be your major table? I'll show you why I used it. Let's try the same one. And let's try left outer join. See the difference. I'll show you the difference. You'll see the difference yourself, and then you'll say, oh, now I see why you are saying the other table must be the major table. Why is job desired the major table? Right? Why is not the other table the major table? See what's the output is now. I've done the same thing, but in this case, I've made this table as my major table. I've used a left outer join. Right? Now see the answer. Everybody in the my contacts table looks for a partner in the job desired table. If somebody gets a partner, 7 will get a partner, 1 doesn't get a partner, 2 doesn't get a partner, 3 doesn't get a partner, 4 gets a partner, 7 gets a partner, 7 gets a partner again, says hello every time, and so on. Now you have extra records in your table. What do you want to remove? You want to remove this one, this one, this one, this one, and this one. You have to remove 5 records because that's not the answer. That's not the right answer. I have to add another condition saying, oh, please remove this extra ones. Why did the extra ones come into existence? Because there could be many contacts. Not all of them want a job. So therefore, using a right outer join, right means, I mean, it doesn't matter whether you use right or left, but using job desired as your major table was important. So now to make this answer right, what will I have to do? I'll have to say, remove this record, remove this record, remove this record, remove this record. Okay, how will I remove it? I'll have to add something to it. I'll have to add another condition. And the condition will be where the JD's contact ID is not null. Only pick up those records. So extra work. Extra statement, extra work. So in the first one, you used your job desired table to be the major table. It was your starting table. Why do I say starting? Because it's a right outer join. In this one, you used the left table as your starting table. You can reverse and do whatever. I mean, right and left only says who is my major table. So now if you start from the master contacts table, everybody is in the MC table. Everybody. Now, but I am not interested in everybody. I'm only interested in people who have a partner in the JD table. So I have to put an extra condition. So this itself tells you that the outer join from 231 to 234 is more complex. So if it is more complex, it will take more time. It has an extra condition. It's like anything. If I say, oh, say hello, you all say hello. But if I say only say hello if you are wearing the color red, then you will look at your shirts or your sweaters. Oh, am I wearing red? Only then I say. So extra condition means extra time. We don't want extra time. Why should we spend extra time when it can be done in a different way? Now you will have the right answer. But I had to put a where condition. I had to. There was no other way. Now I'll get the right answer. See, gone. People with which had the not null are gone now. So I don't want to say hello to people who are not desiring a job. So I don't want to say hello to people who are not wearing black. So I had to remove them. So I'm saying if you are wearing well, you're not null, I'll say hello to you. Okay. So there is nothing wrong in the answer. They are both right answers. But from programmer point of view, or even from a layman point of view, which one is more complex? The second one is more complex. Your second query is more complex because it has an extra condition. But it will work, and it does work. I had to put an extra condition. So think a little intelligently when you're doing something. What do I need? Which table should be my major table? And then doesn't matter whether you write it on the left hand side or whether you write it on the right hand side, use the right outer join is the important. If you write it on the left, use the left outer join. If you write it on the right, use the right outer join. But use the right outer join, the correct outer join, wherever you place the table. It doesn't matter. You'll say, oh, can I do this by writing left? Yeah, it's not a big deal. I can write this using left. See, what will I do? I'll make it left. I'll take this table, put it on the left hand side, and take this table and put it on the right hand side. It is still the same. It is still the same. Still the same efficiency. They both are efficient. I don't need anything extra here also. What did I do? I converted right into left, and I took this table, which was the major table on the left hand side. So right and left are not different as per se. I mean, all you're doing is swapping the table. But which one is more efficient depends upon which did you make your major table. So in the first two, I made job desired as my major table, and I didn't have to do anything extra. No where condition was required. But in the second one, when I chose to make the other table as my major table, maybe just blindly, then I had to put in an extra condition. Right? So efficiency is important. Therefore, in my questions, if you notice in the assignment, it says, please write non-redundant and efficient code. That's what I'm trying to stress. Just don't write it blindly. Think about it and write it. And therefore, I've given you a group assignment so that you can discuss with each other. Please understand, don't do that assignment. You do half and I'll do half. Don't do it that way. You do the queries, sub-queries, I'll do the join. Don't do it. You won't pass in the final exam. I want you to do it together. So you do it together, both of you may do it, and then you can discuss it or sit together and do it. But do the whole assignment. Don't divide it halfway. Or you can do, or I'll do 3 joins and 3 subs. You do 3 joins and 3 subs. You both get practice of both of them. Please ensure that, because in the exam, you will have both joins and subqueries. Okay, now let's write this subquery. I'm looking for people who want a job. Okay, so how do I get that? I'm looking for people who want a job. These people are looking for a job. These people are looking for a job. Right? Now I want their names and their phone numbers. So these are people who are looking for a job. Now I want their names and their phone numbers. So select. Oh, now you can remove the star also. Sorry, the star was put so that you could see everything. If you don't require this thing, don't put it. Now, I'm looking for these people. As long as as long as their contact ID, where their contact ID is in this list. Subqueries kind of work this way. The inner query or the sub works first, and they are independent. I could just pick this up and run it. You can do that in a join. Join is combined, but here subqueries you can run in parts. So these are people who are looking for a job. 4, 7, 7, 8, 9, 10, right? Now I am saying, go to my contacts table, pick up everybody's name and phone number, but check, is their contact ID in this list? If it is, show me their number and name and number, otherwise don't show it to me. So I do it in parts. Subqueries are done in parts. So here is a list of people looking for jobs. Now I say, now get me the name and the number of all those people who are in this list. But this will take more time. Why? The whole my contacts table is being scanned, and every record's contact ID is being compared with this list. Are you in the list? Yes. Spit it out. Are you in the list? No. Oh, I don't want your name and phone number. So this will take more time. It will take more time than a join will. So sometimes joins take less time, sometimes subqueries take less time. Again, it's not a guess, it's not a guessing game. A programmer will always know which will take less or more time by virtue of the code. So definitely you are saying, oh, every record in my contact, it's like saying every student of Georgian College is asked that question. Do you live in Berry? Do you live in Berry? Do you live in Berry? You know what I mean? That's asking every. So it's the same thing. Every contact ID is picked up. And if their contact ID is in that list, live in Berry kind of stuff. Are you in this list? Or we can say lives in Berry or Owen Sound or Aurelia, something neighboring, right? So are you in that list? Do you live in that list? Yes. Here is your name and here is your phone. Are you from here? No, you're from Toronto. I don't want your name and phone. So definitely it will take more time. Every student in the college, there are 5,000-6,000 students in the colleges, ask this question. Do you live in Berry or neighboring areas? On the other hand, if I go the other way, I get the contact IDs of people who live in Berry and just kind of look up their name. That's much easier. Okay, so you just have to think which one is more efficient. And programmers have to do it. It's their job. Okay, so that question should work. Let's see if it works. So all your 1, 2, 3, 4, 5, the last answers should be the same. So I've answered a query in many ways. So 1, 2, 3, 4, 5. Remember 7, 4, 1, 8, 9, and 10. Same answer here. Same here. These are the 2 outer joins, 3 outer joins. 1 inner join, 2 inner join, 3 inner join, 4 inner join. All same answers. This is an answer of a previous one. So all 7 answers that I've written are giving you the same answer. And that's what you have to practice. And that's what I've given you the assignment. Write it using joins, write it using subqueries. Do it in more than one way. Use the max function, use the min function. And it's all your practice. That's like a review of your final exam. Whatever I'm doing now is also like a review of your final exam. So in the final exam, I'm not going to test you on can you create a database. I'm not going to test you, are you using the best fit fields? That's not my aim. My aim is can you use inbuilt functions, alter, and joins and subqueries. That's your new thing that you've done after your midterm. Right? Why do I say inbuilt functions? We did advanced select statement, min functions, max, count, and so on. Okay, let's go to the next question. So it's just 1 by 1 that you do it. Now, what does 2b say? It says, okay, Anju wants to be a computer programmer, but is there a computer programmer listing in the market? So it says, now see if there are any job opportunities for them as listed in the job listing statement. So, okay, Anju desires a job, my name and my phone number. But in addition, I also have to check, is there a computer programmer job in the market? If there is, then I would like to know your name and phone number so that I can call you. So maybe I want to be a chef, but there is nothing in the market. So the company doesn't want to call me. You know what I mean? So the guy says, oh, So the consultancy is saying, oh, I don't have to call Anju because she wants to be a chef, but the listing doesn't have a chef. So now think about it. Which tables do you want? The name and the phone number are coming from my contacts, one table. Who desires a job? From the job desired table. Which jobs are listed in the market is coming from the job listings table. So now I'll have to join 3 tables. That's all I can do. So are you desiring for a job? Yes. Is the job that you're desiring for in the market? Yes. Okay, now what is your name and your phone number? So you need 3 tables. We need 3 joins. So joining of 3 tables, and in subqueries, the levels will increase. So let's try writing it. Okay. So the whole thing, the whole practice of this is making you do things one by one and kind of adding to it. Okay. So let's try this now. Now, since we've done joins, and I just want to cheat a little in the sense I don't want to write it again. So 2A, I have this. People who are looking for a job. People who are looking for a job. And what is their name and their phone number? Now I have to add another table to it. Okay, add another table. What is the third table that you want to add? The job listings table. That's why it's 2A and 2B. Let's call it JL. Again, the names are just made by me. They're called alias names, also known as alias, right? So you may use it if you like. If you don't want to, then you can use the full name. But we found out that if once I give it an alias name, then I have to use the alias name throughout my query. Okay. Okay. Now what? Let's go back to the table. This table needs to be joined with this table, needs to be joined with this table. These 3 tables have to be joined. So these 2 tables are kind of, oh, this person is looking for a job. So that's how I get his name from here. What is the connection between these 2 tables? There is no line between them. So it's not saying, oh, I'm a foreign key, title there must occur here. But what is the logical connection between these 2 tables? Job title. If I'm saying I desire to be a computer programmer, then this title must exist in the listings. I mean, then I want your name and phone number. Make sense? So if I want to be a computer programmer and a computer programmer job is listed in the job listings table, then I want to show your phone and name. So how do I add that condition here? Help me. How do I add? All I do is this. I just add it, like add it, and JD's title. Yeah, this is complicated, but you just have to kind of go one step at a time. If that gosh was coming for, oh, this is tough. There, add your condition. Brandon just said title is common, and it is. Again, this field could have been called entirely different. Here, maybe it could have been called job title in one, maybe it could have been called only title in the other. It's not important that they be called the same. What is important is that you recognize that they are connected. And this connection was not showing in the diagram because there was no foreign key kind of combination there. Those lines only come up if there is a foreign key. But this is not a foreign key. I could be desiring a job of marathon runner, and it's not in the job listing. That doesn't stop me from desiring the job. So I can't say, oh, a title in the job desired must exist in the market. That's a complete wrong assumption. You could be desiring to be anything, and it may not be in the listing. So it is not a foreign key. It is not a foreign key. The line is not there in the diagram, but that doesn't mean that condition doesn't exist. So what have you done? You've said these 3 tables have to be joined. The name has to be picked up from my contacts and phone. You don't even have to qualify it because these fields are nowhere else. If you wanted to, you don't have to. But if you wanted to, you could say MC dot. You could say MC dot. But you don't have to qualify them because there is no ambiguity. Phone only occurs in MC. And name only occurs in MC. So there is no ambiguity. You don't have to do it. So if it helps you, sure. Oh, this field is coming from this table. This field is coming from this table. But if there is no ambiguity, then you don't have to. And you've given your joining condition. My job is done. All I did was add a third table and add a condition. Now I would, if I were you, I would use my trim function on my varchar fields. Though I think, I'm not very sure, but I think automatically MySQL does it. If there are extra blanks on either side, it just removes them when it compares. It ignores padded blanks on either side, not in between. So computer blank programmer is not the same as computer blank programmer. Blanks in between matter, but I think MySQL will automatically delete the blanks when it is comparing, not delete them. When it is comparing, it will ignore the blanks on right and left. Because I'm not very positive, I've still put them here. So trim is just saying remove them. When you compare it, remove the extra blanks. There it is. There's your answer. So these people are looking for a job and the market has it. So let's look. What does the market have? Okay, so here is what listings are available. Baker, clown, dog trainer, whatever, web designer, and a computer programmer. Let's see who's desiring for a job. So 7 is looking for computer programmer. Oh, there is one in the listing. 7 is also looking for web programmer. Oh, there is one in the listing. This computer programmer is also looking for a job. He has a job. Sales manager, I saw a baker. I'm not sure about chef and sales manager. Baker is there. Chef, there is no job for the chef and there is no job for the sales manager. Okay, so what should be in my answer? 1, 2, 3, and 4. 4 people who are looking for a job. They could be the same person, but 4 people are looking for a job and it is in the job listing. So I should have 4 answers, 4 records in my answer, right? And now, do I require distinct? Depends. Distinct is, in this one, distinct is not making sense because 7 is looking for 2 different jobs. So I want to see who are you looking for? You can always add it. Do you want to add which job are you looking for? Here, put the title here. Pick it up from anywhere. What job are you looking for? You can always add it here. That way we will know that your answer is right. This will tell you what job are you looking for. 7 is looking for 2 jobs. Notice I removed the word distinct. Why? Because 7 was looking to be a computer programmer and a web programmer. So I want to see him twice. I'll say, oh, you have a job for computer programmer. Oh, I have a listing for web programmer. So this title will tell me what job is the guy looking for. And I've removed distinct. This one does not need distinct because 7 is looking for 2 jobs. Let's run it. And I have an error. MC concat doesn't exist. It didn't like the word MC in front of it. Oh, I see why it didn't like it. Oops, I'm so sorry, guys. My bad. MC dot first name and MC dot last name. I'm so sorry. You have to qualify the fields, not the function. Right? Now we should be okay. See there? John wants to be a baker. Renee wants to be a computer programmer and Angelina also wants to be a computer programmer. I'm almost positive I saw a web programmer in the listing, unless it is misspelled. So the answer is missing web programmer. Job listings had a web programmer, didn't it? Oh, web designer. Oops, my bad. I thought it was a web programmer. It's a web designer. There is no job for a web programmer. So my answer is right. 2 people were looking for web programmer and 1 guy was looking for baker. So I have 3 answers. Baker is available, yes. Computer programmer is available, yes. And because 2 people are looking for it, I want both their names and phone numbers. And somebody was also looking for web programmer. If you want to kind of change it, just for the heck of it, change the web designer to programmer and see, this will come up. Same spelling, don't mess up the spelling. Lowercase, uppercase doesn't matter because I'm not doing that. There, I've changed the web designer to web programmer just so that you can see the answers. And now you'll have to run the whole script again because tables have changed. And now that 7% who was looking both for a web programmer and a computer programmer will show up in the answer. There you see, Renee is looking to be a web programmer and Renee is also looking to be a computer programmer. So that helps me, adding the title helps me to say, oh, what job are you looking for? If I put distinct, then I'll only see it once. But I don't want to put distinct because I want to see the two jobs the person is interested in. So putting distinct is just not saying, oh, I have duplicate answers, let me put a distinct. It depends upon what you are looking for. So I'm looking for all those people who want a job and the job is in the market. And there could be different jobs. Renee wants to be a web programmer and Renee wants to be a computer programmer. So I want to see both of them. Right? So nothing is impossible. It just takes a little bit of time and practice. And because I'm a little better off in practice than you guys are, I'm just doing it off my head. Believe me, it will take time. It takes time. So now I just added the title because I wanted to see it. Now see if there are any job as listed in jobs, show their title. So add this, show the title too. I added this. So you can change the question. I've said show the job title also. To make things clear for you. The first one was only saying, oh, you desire a job. What is the job? Now I have also said it's in the market. Now I want to call that person. So if I call Renee, I can tell her, Renee, there is a job for the web programmer, and Renee, there is also a job for the computer programmer. Right? So it's a lot of thinking. It's not easy. It just takes a little bit of time. And I changed my web designer to web programmer. If you don't have this answer, if your answer is not matching mine, maybe you didn't change it. Maybe you were not paying attention when I was saying change the web designer to a web programmer in the job listings. I changed it. In the job listings, I changed the web designer job to a web programmer job so that I could show you that Renee will come up twice. And I don't want a distinct. I want to see her twice because she is looking for two different jobs. So where do I use distinct, where I don't use it, what is required in the question? You all have to put your head together for it. And that's why you have 1 week for that assignment. Don't put it on the last date. I'm telling you, it will take time. And 2 people together, it will take time. Okay, so that works. This is using a join. Now again, you can remove the comma, write the word inner join. You can remove the word where and put on and so on, whatever makes sense to you. Okay, it's not a big deal. I mean, I can do it. It's just that it takes time every time I do it. If I was writing it using the word inner join, it's not a big deal. I'll write it like this. You'll say, what happens? I have 2 conditions. No big deal. Whenever you use the word inner join, you can use where or you can use on. Both will do. That's all. You just put, you still say and, or you can say where. Both will do. And actually, you can even use natural join and not give the conditions at all, because by default, again, the fields are named the same. The fields are named the same and you're looking for equality. Now the trim thing is something that you cannot kind of, I don't know, I can double check if MySQL does it automatically, but I'm not sure. If it doesn't, then it may not match. You can double check. But you can use natural join if there is no, there is no problem if you think, oh, that's okay. And I'll give you with outer joins also. It is a little tough, but it's still doable. You can combine joins. You can take one as inner, one as outer, both as outer, all 3 as inner. It can be done in many ways. I can give you 3 more solutions of it. Let's try this. And all my answers in the last 1, 2, 3, and 4 should be same. Last 4 answers should be the same. I've written it in 4 different ways. With 4 I see an empty table somewhere. Okay, so where does the answer start? 1, 2, 3. Okay, natural join isn't working here. Let's see why it is not working. It's an empty table, so something is wrong. It is not working. So it runs. I don't have an error. Do I have an error? No, I have an empty table. I don't have an error. If I had an error, I wouldn't. Yep, I don't have an error, but natural join isn't working. So maybe syntactically you can't use natural join when you have more than one table. You can only use natural join between two tables. That's the only possibility I can think of. So I take back my words. If I see an empty table, that means this will not work. So remove it, please. And we know something now. Natural join you can only use natural join when you're dealing with two tables. It's a syntax. I can change it. I didn't think of it. I just did it as logically. I thought, oh, I'm doing a natural join, but maybe my SQL engine was not made that way. It's not that smart. It can't say, oh, if you have more than one natural join, join this with this with this, and use the economy. It doesn't know it. You don't do it. Not a big deal. Now let's try using outer joins. We haven't finished yet. Oops, I'll give you a break. Then we'll do the outer joins. Okay. So I can put this on Blackboard, maybe as a separate file today because we made some changes. And then you can pick it up. Okay. Take a 20-minute break, please, and then come back and we'll continue to do this. Oh, it's so warm in here.
I swear I've heard someone say that before.
Group assignment, not like anyone.
What did I say? If you need a partner, you have to tell me by Wednesday, right? When I posted the assignment. Because people were emailing me. Anybody else who's looking for a partner? There. I won't take individual assignments for your group assignment. I want it's a 0 straight away. So I said, if you need a partner, let me know and I'll hook you up. So you have a partner now, okay? Anybody else looking for a partner? Guys, when an announcement is put, why don't you pay attention to what it says? Anybody else looking for a partner? There. You guys are not paying attention to announcements, that means. Pair up, okay? Anybody else who doesn't have a partner? Another one. Anybody looking for a partner? Anybody else? Okay, so you send me an email. And if I find somebody, I'll hook you up. If not, then you may have to work with me. But you send me an email, okay? And I'll put an announcement on Blackboard saying anybody looking for a partner. Like you, maybe somebody else is also still sleeping. No individual assignment will be accepted.
Do you know why there's so much like security and like cops and stuff around here?
Yeah, I saw today.
Yeah, do you know why?
I'm not sure. No, I didn't ask. There was something in our department, the first robotics thing, but
yeah,
I'm
I
not sure if
saw that.
that's.
Yeah, I don't know
I
why
don't
there'd be
think
so
so,
many
right?
security for that. That
Yeah,
seems
why would you
weird.
need security for that?
Yeah.
And I saw some sniffing dogs also.
Really?
Yep, they had
okay.
dogs. Yeah,
I didn't see any of those. Wow.
no, yeah, when I was coming in, these were security. I mean, these were police guys, I'm assuming, and they had sniffing dogs.
Oh wow. Okay.
So I don't know what's going
Something
on.
crazy's going
Something
on.
is-
Yeah.
Yeah, but we don't have any emails, so I don't think it's anything dangerous as for the
exactly.
students.
There's blocking.
Yeah, but maybe they're looking for something. Now that you say it, yeah, there was sniffing dogs too. Yeah, sure.
But can you, after you finish and you upload the file on the record? Yeah. I'm not feel clearly in the John and
What is the difference?
Yeah, different.
Okay.
How different?
Okay.
And left, right. right order,
Okay.
yeah, and
Mhm.
left order.
Okay. Okay. Let's take an example. I'll do an inner join. Okay. So let's put an ID field.
Yeah.
So table 1 and table 2. Let's put a name. So then ID is 1, 2, 3. Name is A, B, and C. Right. Let's again have ID. We can call it the same or different, doesn't matter. So let's say 1 and a 4. And let's say 1 has A and 4 will have a D. Okay. Let's do table 1, inner join, table 2, and let's join them on ID field, right? ID is equal. Okay. So 1A has a partner 1A. So your first record will be 1A, 1A. So ID name from this table and
Table
ID
1 and
table
table
2.
2.
Okay. And it says, oh, I found a partner. 1A says hello to this. No, they don't match on their ID. So it doesn't say hello. Remember, on ID is equal. Okay. 2 says, is there a 2 here? No. Gone. 3 says, is there a 3 here? No. Done. Finished. That's an inner join.
Mm.
Okay. So inner join says this,
We
every record of this will talk to every record of this trying to find a partner.
Or we have to take the
Every
same.
record. Yeah.
Every
Depends
every
on what you
same.
want to do. I'm doing it on ID equal. I could have done it on ID 1 is greater than ID 2. I could have said 1, this ID should be greater than this. So, okay, so now join. 1 is greater than 1? No. Is 1 greater than 4? No.
No.
Is 2 greater than 1? Yes.
Yes.
Okay. So 2B will say hello to 1A. It depends upon your condition of join. This is called the join condition. It depends. What are you joining on? Okay.
Yeah.
The join condition is important. Okay. So 2 is greater than 1? Yes. 2 is greater than 4?
No.
Is 3 greater than 1? Yes.
Say hello.
Say hello. Is 3 greater than 4? No. Done. Job. So the joining condition tells how to join.
Yeah.
Okay. That's an inner join.
Yeah.
So every record talks to every record, but only joins if the condition is satisfied. So check. True, yes. Not true, don't. Okay?
Yeah.
Now let's look at the outer join. Let's take table 1, outer join, table 2. And the difference between right and left is only this. If I say left here, I start with this table. If I say right here, I start with this table. That's the only difference, okay? That's the only difference. Okay, so let's start with the left. And there has to be a joining condition again. So let's join on ID 1. When I say ID 1, I'm talking of the first table, and ID 2.
Yeah.
Okay, so now what? So the first picks up and it says, oh, I found a partner. Right? So this is my major table left. Every record of this table will be picked up one at a time. 2 picks up, 2B. Does 2 have a partner here? No. Does it match with 4? No. So what will happen is 2 will pick up, but it will say, oh, I didn't find a partner. Okay?
Yeah. It didn't find.
It didn't find a partner, it will say null and null for the other fields of the second table. Okay? 3 didn't find a partner? No. This will be the result. So notice how it is different from this. If here
It take the same and it take the not same.
Yeah, it's also doing the same, but if it didn't find a partner, the record will still show the answer and it will have null. Here it doesn't even show the answer.
In answer.
Yeah.
Yeah.
Okay. Inner join will only join if it finds a partner. Outer join will join, and if it doesn't find a partner, it will put null.
It's everything.
Everything.
Yeah.
But it will put null.
Yeah.
Right. Okay. So now this is.
It's so detailed.
Yeah. Okay. So now let's do this. Let's say table 1, right outer join. Table 2.
Yeah.
Therefore, I put a where condition. I say remove these. When I put a where condition in my outer join, if I want to remove this, I say remove where ID of the table 2 is null, and I can remove these records. That's where I do it. Okay, so let's do this. Outer join, table 2. Okay, now table 2 will be the major table. So 1A, so these ID fields, these name fields are of table 2 first. Okay?
Yeah.
These were of table 1.
One.
Okay. So these are the two, and these of table 1 on the other hand side. Okay. 1A finds a partner. 1A, yes, I found a partner. 4D did not find a partner. Then it is finished. It has no other records here. That's the difference between right and left. Who is the major table?
If the table 2 is have 2, if it have 2
Only
here,
if it has 2, it will join
Yeah.
hands with this one.
and it's so here,
Yeah, but now then it will say 2B, 2B.
B, yeah,
But if it had it, if there was a 2B, then it would say 2B2.
yeah,
I don't want to put it here because then these answers will
yeah,
not
yeah,
match.
yeah.
So that's the difference between right and left. Which table is the major table? Here I started with this table trying to find a partner. Here, when I say right, I start with table number. So which is the big major table? Who is the head? Who is the master?
Yeah.
That's the difference between right and left.
Who the first and who
Who's
the
the, yeah,
master.
right? Who's the master? Here inner join just says, if you find a partner, good. If you don't find a partner, nothing. But here that nothing changes to. Okay?
Yeah.
That's the difference.
Make it
Make sense?
Yeah.
Okay.
But the assignment 1, I don't understand the function any.
Yeah, this is an operator. You have to
Yeah.
look it up, research it a little.
Yeah.
Okay? Any and all, I've given you 2.
Yeah, 2, and I saw something is it give me 2 x, y, any, and function blah 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 here. But
Show it to me. Open up.
And then so here, if I just wanted to have like certain image, I would just replace it with like image.
Welcome, welcome.
You open it up.
Show me the question.
Oh, saying this means that it's the source here. Oh, okay, yeah, okay.
It says just so that you know the verb in is equal to in. So remember we did the in verb, I've done the in verb.
Like if I basically
Yeah,
want
so if I say in a list,
this image with this image.
you can replace this is in by is equal to in. It's the same.
You could do
That's what I mean. This is equal and they are both the same thing.
Or you could
That's what I'm saying.
yeah,
Okay?
yeah, okay.
And we haven't yet done all of them, so we can't answer all of them yet. We'll have to wait till the Monday class. Okay?
Thank you.
Yeah, I haven't finished yet.
Yeah,
Yeah.
I know.
No problem. You try, but don't feel bad. Oh, why am I not getting it? Because I haven't taught it yet.
Yeah, but I just something and I understand that.
Sure, sure. So on Blackboard, there are more scripts. Once we finish these ones, then we'll go to this one, okay? But I'm adding what I did today to here. What I'm working on today, I'll add it here also. It's called, I think it's called classwork now. Anyway. W18.
I don't know yet, to be honest.
So download the other files and then we'll work on it after I finish this, of course. Okay, let's do another outer join for this one, and then I'll go to the join and subquery. But this can be done in other ways too, okay? But again, I can do all, but there are many. Okay, now let's try an outer join, just because when you think of outer join, whenever you are kind of saying, oh, I have a smaller table which I want to pick up some and not all. For example, people listings has another, just some records. Job desired has some records. And the my contacts has so many records, but you're only interested in some records out of them. So whenever you see something like this, you kind of think, oh, I'm looking for something that is here and here, or here and not there. You know what I mean? Like they are in my contacts, but they're not desiring a job. So whenever there are things like this, kind of put your head together and see if you can do it. So if I can go the opposite way, instead like this way, there are certain jobs in the job listings. Yes, there are, right? Of these certain jobs, I'm only interested in the jobs that somebody is desiring. Yes, there are. And then I want their name and phone number. So if you can think of it this way, I mean, think of it another way. That's what it is about, but opposite. In the listings, there are some listings. Am I interested in all listings? No. I'm only interested in those listings that are desired by somebody. Oh, so they're here, but not here. And then I want their name and their phone number. So if I can think of it that way, let's see if I can do it that way. So what I'm going to do is I'm going to select again so this remains common. What you need to select remains common. Right? Again, you don't have to qualify if there is no ambiguity. You can put a note for yourself. You do not have to qualify. Qualify what? Field names. If there is no ambiguity. Ambiguity. right? So you don't have to say MC here for your information. And I'm only talking about qualifying field names. Okay, now let's see what do I have to do. I have to pick up the name, concatenate, and all that is common. I don't have to do much in it. And the title and so on from. Look at what I'm trying something. So I'm saying you are in the desired one, but you're not in the listings, and then I get your name and so on. So bear with me while I type it, and then we'll talk about it. Okay, so what am I looking for? I'm looking for I'm going to do a left outer join because this is the smaller or the major table, not smaller. I mean, I shouldn't be calling it smaller, the major table. I'm going to do a left outer join of the job desired with the job listings. I always kind of think, why do I choose a major table so that I don't have to put conditions like where it is not null or where it is null. So avoid those. So everybody who desires a job, if he can find something in the listing, because that's the main thing. It's not the opposite. I don't want to say, oh, it's in the listings and it's also desired. I'm saying, does somebody desire that job and is it in the listing? So I did a left outer join, and again, we'll give them names just because. And you don't have to, just because it's easy to kind of write them. So do a left outer join of job desired with job listings on what condition? You can write it on a different line because if it makes more sense to you. Some students like it this way, so I'll do it this way. On what? I want to trim on JD.title is equal to trim on and the other table was job listings.title. Okay, so I've done a left outer join. When you use a left outer join, you can only use on. You cannot use where at all. It's not allowed. Where is not allowed. In an outer join, only on is allowed. Okay, so what did I do? I said, pick up the desired table, see if it can find a partner in the GL table. Right? And if it can find a partner, good. If it cannot find a partner, then it will be null on the other side. And then, let me write it and then we can discuss it. And then whatever I have makes a left outer join with the table my contacts. Now I have to find their name. So this is an easy one. Because I want to find their name. And the joining condition is their ID. I've only used left outer joins here. You can actually combine a left outer join with an inner join and still get an answer for this query. If you want, I'll put it afterwards and put it on Blackboard because as I said, there is no end. But in the exam, I won't ask you for 5 different ways necessarily to do the same thing, but you should, this is just for your own learning process. Okay, so this one should not be so tough. This last left outer join should not be so tough. All I'm doing is, if you are in the job desired table, then I want to pick up your name from the MC table. So that's fine. Look at the first part of the query. The first part of the query is doing an outer join between job desired and the job listing. So it is saying, if you have a title here and you have a title there, join. Right? So let's do it one by one. Maybe, no, with that join, it's kind of very difficult to do it one by one. Cannot because it's, let me do something for you for a minute, okay? You don't do it. I'm just going to say select star. And I'm only going to kind of run this query inside one. So what I'm doing, I'm showing you how the job desired table is being connected to the job listings table. I'm just showing you this result for now, okay? I've only picked up this. So job desired table has said hello to job listings table. These are the jobs that are being desired. These are what are in the listings, and I'm only interested in which guys? Anybody who has a partner. I'm not interested in the last two ones. The sales manager and the chef did not find a partner, right? They didn't. So this is right. There's nothing wrong in this table. So I took an outer join, and from the job desired table was my major table to the job listings table, and my result is right. Right, so the result is right because I did an outer. Now I'm only interested in the names of this, and this. These four are what I'm interested in. The rest don't matter to me. So what should I do? So the select star was only put so that you could see it. So that I could show you, yes, I'm doing the right job, right? So I said to job desired table, I said, go and find a partner in the other table on the title. So it found partners. Whoever found a partner, good. Whoever didn't find a partner has null in its two fields. Now I said, whatever is this resulting table, this is your resulting table. It says, okay, now from here, I want to do a left outer join with MC on the contact ID. So contact ID, but not these two. 4 and 9 have not to be included. So what should you do? You should add a condition here. You should say on and add where. You don't want these ones, these null ones. And whose job ID is this? This is the job ID of job listings. Only pick up those records where the job ID is not null. Only pick up these four, 1, 9, 13, and 13. Job ID is not null. And notice how I've said JL job ID. It doesn't like something because you can't put, I think, unless, I think, yep. You can't put it in between. You'll have to put the condition at the end. So it didn't allow it. That's all. Syntax wise, the condition goes here. It says all conditions of where come at the end. It gave me that red squiggly. So I made an educated guess that it has to be put at the end. So the where conditions have to be put at the end, any where conditions. So please understand, why did I put this where condition? That is very important. Why did I put this where condition? Because I'm only interested in the first 4 records. I mean, I'm saying first 4, it could have been anywhere, but only in the first 4 records where the job ID is not null. Because these are people who are desiring a job and there is a job in the market. So I made a left outer join of the 2 and I only chose those records where job ID is not null. And please notice whose job ID is not null. JL's job ID is not null. So pick up 1, 9, 13, and 13. And then now make a left outer join with MC on the GAD's contact ID. GAD's contact ID. There, now it should work. It should give you the same answer. So whenever you're going to try outer joins, I would recommend that you do a select star first, do an outer join, see your result and say, oh, this is what I want and this is what I don't want. And then put a where condition for what you don't want or what you want. So if you kind of think of it, I just went step by step. People desire a job. Is it in the listings? So only find those jobs which are in the listings. Once you have their contact ID, give me their name and their phone number. So it's just practice. Believe me, it's just coming from practice because I've been doing it for so long that I know it better. And I know that it is your first time and it will take time. So don't sweat about it. It just takes time. And I'm telling you, there are other ways of doing it. I'm not going to kind of, slap it on you because I can do it in 2 or 3 more ways, but I'll kind of shut up here because one was pure inners and one is pure outers. But nothing stops you from combining them. You can say, oh, I'll do an inner join of these and do an outer join with them. I'll do anything can be done. Like as long as, of course, it's logical. And now the next question, which one is the most efficient one? That will take time to understand and think, which is not in your course, but it will take time. Oh, this one works better than this one because it's doing this the least number of times kind of stuff. Okay. Okay, now like the next one, let's do a subquery. So if you want, I will put 2 more answers. I know how to make an outer and an inner join together, just so that you know. I'll put them afterwards, just so that you can look at them, just for your information, okay? Okay, now let's go and do a subquery for this. Let's see if you can do it with me. What does subquery say? Subquery says find it, and then if you are here, do it. Okay, so one step at a time. Subquery, I find subqueries to be easier to explain because it's more of a. Let's first only select the title from the listings. Because ultimately I'm only interested in what is in this listings. Okay, so that will give me all the titles in the listing. You can trim it if you like, because we've been trimming it. You can always clean your table before even working with it. You can just trim the fields and update them, which is what usually should be done, right? Data is entered, and after that it should be cleaned first before you start querying on it. Cleaning means removing any extra blanks or changing, altering the structure if you want, and so on. I'm doing it because I have no clue, so I'm trimming my title. Okay, so I've got my titles from my job listings. Let's go a step ahead. Whose contacts IDs are you interested in? You're interested in those contact IDs that lie in this table. Okay, so let's do another select. So select the contact ID from, I'm writing it in one line so that it's kind of easy to read, from the tables of job desired, such that, when I say such that, I mean where the title that they are interested in is in this select. Make sense? So first select the titles from the job listings. That's your first job. So as soon as you start kind of writing them, you start putting them in brackets because it's a syntax. You read it. So now select those contact IDs from the job desired where the title that they are interested is in this job listings title. Oops. And now select their name and their subquery always go up, kind of top to bottom. Uh-oh. Just because I'm not qualifying it, I'm removing it from here. Oh, and we'll talk about something. We may not be able to do it. I may not be able to show you the title. That was just a tab. Sorry. And I'll have a small problem here. Oh, not you. Syntax wise, I just have to be careful of where. There. Let's go in the reverse order. Subqueries, you have to kind of think of and write them in reverse order. And I'll tell you what problem I'm going to have here. And they're all independent. That's one part of the subquery that you can run them independently. That means I can pick this up and see, bear with me. I'm only selecting titles from the table. Makes sense? All titles have come up. Now I'm only interested in those people, the contact IDs of those people who are looking for a job in this list. That's query number 2, 7, 7, 8, 10. And now I am interested in their names and I'm going to get an error. And I'll explain you what the error is. Logically think about it. So what does these subqueries work? I have 2 subqueries here. I have 3 selects and there 2 of them is in, right? So I first find out what's in the job listings table, what titles. Now I pick up those contact IDs from the desired table where their title is in this table. Makes sense? And now I'm interested in their name and their phone number. Before I run it for you, what do you think? I think I should get an error. What do you think should be the error? Which was not coming in joins, but will come here. Look at the third field, the JD title. if you kind of think, I told you they're independent, right? Now, is the title available here? Now, even if I call this JD, where I don't have to, but anyway, even if I call it JD here, I can get it because subqueries are run independently of each other. So when I come to line 100 to 81, it doesn't know what JD title is because the subqueries are given. I think logically I should get an error and it should say JD title doesn't exist. If I remove it, it will work. Let's try it. So do I have the same answer? So here, till here I'm okay. All jobs in the listings works. People who are interested in these jobs works. Now their name and their title. Now I have to think a little. Now their name and their title. And I get an error. It says, who is this title? You say you were okay till now. We were not having this problem because joins are different from queries. Joins, everything joins. So the resulting table is all fields of one table plus all fields of another table plus all fields of the third table. I was joining 3 tables. So I have everybody's fields at my disposal. But in a subquery, it's going step by step. So when it reaches the last select statement, it has no clue of the JD title because that was a subquery. It has already been done. It will run if I remove this. I don't need the title. I don't need the title you are interested in. It will run now. It will be fine because these 2 fields only belong to from table. Notice these fields, whatever you select here should only come from this table. Now if I run it, I'm okay. But the problem, look at the problem now. I have no clue and Renee is only coming once because it's not showing me that Renee wants a job twice. Because title, I've removed the title. I can't do this. So it's kind of incomplete. So if you don't want to show the title, it was good enough. But if you want to show the title, it will not run. It can, logically, it will not. Right? So subqueries do have their drawbacks. So if I don't want the title, you can show the title. This is for you. You cannot show the title. It cannot be done. No way can it be done using a subquery. I can join the 2. I'll show you the third comment. If you see, I can combine the 2. But in a subquery, I cannot show you the title from another table because it goes one table at a time. Look at the from this table, from this table, from this table. You're not joining them. You're just looking at one table at a time. That's all I can get. Unfortunately, it's not a wrong answer. Renee is looking for a job. Angelina is looking for a job. John is looking for a job. The only incomplete information is what job are they looking for. So if you want that information, you can get it from here. If you were only interested in their name and the phone number, you can get it from here. No big deal. And notice Renee is only occurring once because in the contact ID, Renee's contact ID 7 only occurs once. You only pick it once. So I can't do it using a subquery. So some questions cannot be done in the sense you can't get complete information. But what I can do now is, so my third one is, can you combine the 2 and work with me? Why not? Let's see if I can do it. So again, will I be able to show the title and so on? We'll double check. Okay, so I'm going to do this again. I'm going to pick this up again. Right? But I'm going to kind of do a join plus a subquery and see if it works. And what do I want to do it on? Okay, let's do who's my major table? I mean, who would I like to be a table? Let's do a right outer join. Just because it's already written with the other table, which was the TBL job desired table. And call it JD. And let's see if I can handle it now. I have a JD, okay? And of course, I have to give an on. Okay, so what is my joining condition is contact ID is same. Instead of on, you can use using, just because we've done on so many times. I'll just say using. Easy to write and less to write. And don't have to qualify or anything. Of course, you could have written it like this. You will see it is more work. You would have to say MC is equal to JD is here. I've kind of replaced it. Okay. I've joined the two tables. I've said job desired. You will be the master table. You will pick up from my contacts only those who desire a job, and then we will complete it. And then we will say, what do I want to do? Where the title of this person or the job this person is looking for is in. Select the title from the job listings table. Okay, now let's look at what I did. I first found out all the titles from the listings, and then I combined the other two tables using a right outer join. You could have even combined them using like a normal join. But again, one was such a big table, one was such a small table. Why would I use a join? I would use a outer join. You can use an inner join. So you always have to think what will give me a better result. I could have used join into book. Let's try this now. And I should again get 4 answers. Oh, 4 or 3. I have to think about it for a minute. Yeah, because I did this here. See my answer. I have my title again. So only using subqueries, this was not possible. It was not, I mean, I couldn't see their titles. It was possible, but when I say not possible, I mean, I didn't know what title they were interested in. Now I can show the title. Now I can say comma JD title because I'm using a join. You can actually use a normal join also, but this is more efficient. Definitely. Keep in mind, efficiency says, oh, you are doing only how much as you require. Like you could have just said comma here, but just an inner join here. And this will work too. Nothing wrong in this. This will work too. But it is not as efficient as the outer join. Why? Because inner join says everybody says hello, like everybody joins hands on equality. So it kind of checks all of them. But with an outer join, it's only picking up those people who desire a job. And then those 5 people say hello in the MC table. So you're kind of reducing the work. But this will work too. It's just a join, more work, but just a join. You'll say it doesn't matter to me. I know it doesn't. But you're not thinking like a database programmer. A database programmer, poor guy, has to kind of think of a lot of things, of which efficiency is the most important. Think about it yourself. You use search engines all the time. You use Google and Yahoo or whatever. Would you prefer to see your answer in a minute, or would you prefer to see your answer in a second? In a second, of course, right? Because like you can't wait for answers. Same is the case here. You have trillions of records in your tables, and you're trying to do joins and so on and trying to find answers. You want to do it in the minimum amount of time. So I use an outer join. Outer join, I always think of an outer join because I'm saying, oh, I'm here and I'm looking for things here. So I kind of take a master table. So this is less efficient, but inner join can be used. It can be, and I've just shown you. But this level of an introductory course, it is very difficult for me to kind of explain, and on your part also very difficult to understand, oh, which is more efficient or less efficient. It's not easy to understand because you're just learning joins, and now you're saying on top of it, she wants us to say, oh, which is the most efficient. I'm just learning how to join tables. I'm just learning how to write subqueries. I can think of what's more efficient or what's less efficient. But in the long run, you have to think of it. So I won't emphasize, oh, I am looking for the most efficient answer. I won't, because I know it's difficult. But you have to kind of think it that way. Oh, it can be done in other ways. Or why can't I show the title in a subquery? Or why is inner join less efficient than an outer join? So this is for people who want to think. If you don't want to, that's okay by me. I'm fine. My aim is to give you as much as I can. You take what you want to take. So in the long run, if you become a database programmer, then you're definitely going to think which is the best way of doing this. And this will work too, right? So I've given you again a few ways to answer a query, which I'll stop doing from my next example. But this was just because we are doing it. And I want to finish this off so that I can start next. Oh God, 4, 5, 6. Oh God. Okay, let's go here. Lot to do. List titles for jobs that earn salaries equal to the highest salary in the job current table. Okay, what does the question say? It says, I want you to find out, list titles for all those jobs that earn salaries equal to the highest salary in the job current table. So I want to find out what is the maximum in the job current table, and then I want to find out which titles give me this maximum salary. So think about it. What do I need? The maximum salary from the table first. Can you do it? Do you remember the function? To find the maximum? Max function? Right? So let's write that first. And it is only possible using a subquery. So I haven't even done joins here. Why? Because I need to know what is the maximum. So select the maximum from the highest salary in the job current. What was the field called? Salary. Looks like, doesn't like it. From the job. This is an easy one. Current table. That's the maximum of the salaries in the job current table. Now I want to find out who earns it. Which title gives you this? So maybe 100K is the maximum. Computer programmer is getting it. Web programmer is getting it. System analyst, God knows, I don't know. I just want to find out which jobs get the maximum salary. That's my aim here, right? So find out the maximum salary from the table job current. And now all I'm interested in the titles for the jobs that earn these salaries. Okay, so I can't use it. I have to use a subquery. Like you notice, how do I find the maximum? Okay, now let's go one step ahead and try to do this. What do I want? I want the people who are, okay. Select the title from which titles are running it. As I said, this is an easy one. Which titles are running the maximum? I don't know. Is it 1? Is it 2? I have no clue. I just say, give me the title from the table job current. And here you're only using a table, but I'm using it twice. Please notice, I'm using the same table. So I'm talking to the same table twice. You'll say there is no inner join or anything here. There is no other way I can do it. I have to find the maximum salary. And that is a subquery, right? That is a subquery. Find the maximum and all titles that earn the maximum. So I don't know what it is, but we'll know. System administrator is getting the highest, it says, and there is only system administrator. Let's go to the table of job current. You can change it and double check if it works. Job listings, job desired, job current here. 1100 and 1200. There is only one 1200. Yeah, okay, so change somebody else to 1200. Anybody, Unix system admin. Let's change this guy to 1200. Now I must have two answers. So what is the maximum salary? 120K. That's okay. Who is earning it? System administrator also gets it, and Unix system admin also gets it. I just changed it from 110K to 120K, just to show you that the answer will change. The answer is right. There's nothing wrong in the answer, but it should also work with this. So the question was, which titles earn the most? That was the question. So I found out what was the most. I found out the max. And then I said all titles that earn the most. So I'll have to run the whole script again because I changed the data in my table, but I'm only interested in the last answer. So now I must have two answers. System admin and Unix system admin. Both are earning the maximum. So it's like saying, oh, I want to take a course at Georgian. Which course should I take? So let me find out who's earning the most, and these are what gets me the most money. I want to do these courses. You know what I mean? That's where it will come handy. So there is your answer. Before it was only a system admin. Now they're showing both because I changed the data. So if you want to change it, sure. If you don't want to, that's up to you. My aim is to show you that it works. So 3 done. Let's go to 4. That's the only way I can do it. I can't do it in any other way. That's the only way I can do it. Who makes the most money now? So I know that system admin and Unix admin are the jobs that are the most. Now, who makes the most money? All I need to know is kind of, what's your name? So who makes the most money of all contacts? Display their first and last name and their salary, and let's do it. So we know half of the thing. We know what is the most, and then we want to know who is the most. Okay, let's do it one by one. So we want to find out what is the maximum. So copy this. No change in this one. This is the maximum salary. No change in this one, right? So this is the maximum salary. Now I want to find out the name and the salary. It didn't say whether you have to concatenate it or anything. It depends on you if you want to. Okay, and their salary. Right? Okay, so now the salary is coming from another table, and again, you can always go and look here. It's not so difficult here. So the salary is coming from this table, job current, and I want to find out their name. So these two tables need to be joined. Okay, so come back here and let's do this. So from the two tables that need to be joined are table my contacts, and I'll just give one now. I'll just use my commas, okay? And the second table is called job current. So get the name from the contacts table, get the salary from the job current table, and of course the joining condition. Don't forget the joining condition. You can't use on, but you can use the using, which makes it a little easy. And now the condition where the salary of this person is equal to the salary of the, something is wrong. Doesn't like this. So I can't use using with the comma, it is saying. Okay, that's what it is saying. If you see a syntax error, then something is wrong in what your syntax. Okay. With the comma, you can only use where. You can't use on, you can't use using. I thought you could use using. So I just changed the comma to an inner join. So I join these two tables and I say, now please notice something very important. I'm using an equal here. I'm not using an in here. Why? Because this returns a single value. Max is a single value. So you don't say in, you say it's the salary is equal to this value. Right? You'll say, will it give me an error? Let's try it. Will it tell, there's no syntax error. And it doesn't have an, even logically, it doesn't kind of say, oh, I forgot to give its name. So those are the two persons who are, remember there were two, one was a system admin and one was it. But I just want to bring to your notice that you don't require an in here. Why? Because the value is a single value. So I'll put a note for you. Since max returns a single value, use equal instead of in. The in is also working because it's still a list. It just has one value. That's all it is saying. And I forgot as here. And this doesn't need it, but just because I am kind of doing it for the other one. It looked untidy. Look, it was untidy. So I kind of changed it. Once you change once, it just makes a little neater to change the rest. So you can use in, but I would prefer you to think about it. Max returns a single value. You want to do an equality. You're not saying it is an in. So in is working because MySQL says, oh, it's only a value and it is in it. But logically, I would, as a programmer, say that equal is what you should be writing. But we found out in was also working. There it is. That's answered your query. So find out what is the max. And once you know the max, find out who has it and show me their name and only the name and their salary. Now here it says use a subquery but can't show the salary. It's the same thing that we did before. I can't, if I use a subquery, then I can't show the salary because I have tables in different forms. Let me show you what I mean. Okay, so let's copy it here. I say get me the name. I can't do, you'll see I'll get an error. I'm doing it only using a subquery. Same concept as we just did. Give me a minute. Let me just complete it, okay? So if I was only using a subquery, what am I saying? Get me the name from the table, my contacts table. Now the problem is I can't have a salary because it's not in the my contacts table at all. I can't show it because I'm doing it this way. I'm saying, give me the name from the table contacts where the table contact is in this table. Wait, from where you have to just kind of do it one at a time. Okay, now this contact ID, wait, show me the name of the person where the contact ID is in this table, whose title, whose salary. There it is. And one more. Logically, it's fine, but I can't show the salary. There is no way. So what does it say? It says, get the maximum salary. Okay. Now get all those contacts where the salary is the same. We did this before, and it will work. I can work like this. So contact IDs of 2 persons. I don't know who those 2 persons are, 5 and 8. So this is working. But as soon as I try to find out their name and their salary, it will bark at me. It will say, oh, where do I find the salary? I'll get an error because this salary is unknown. So you can do this. Same as we did before. When you use subqueries, you can only extract what is present in that table. So I can show the salary. I'll tell you how to do it though, because it's in your assignment, but I'll show you how to do it. Give me 1 minute and I will. But if I only wanted to do this, I can show you the salary. And I'll tell you a way to get around it. Make sense? So get the maximum salary, again, get the contact IDs of all those persons whose maximum salary is equal to this salary, and now get their names. So logically, there is nothing wrong, but it is incomplete. So I'll show you a workaround, which I said I will. And it will be handy in your assignment too. Right? This is the workaround. Because I'll first find out what the maximum salary is. Remember we did this before also, where we said we want to kind of make it feel foolproof. There, find out what the maximum salary is. Now this maximum salary is basically, what doesn't it like? Oh, it has to be put in syntax wise. I got that problem before also. Here. So find out what the maximum salary is. So I'm kind of doing a little cheating. I'm going to find that value, and I have that value now. I'll just stick it in the answer. Right? I just stick it. I know what that value is. So when I need to show it, now look what I'm trying to do. This is what I'll do. I'm trying to be a little cheeky here. Since I know that value, I'll just stick it here. But it's kind of like, that's why I said it was a workaround. What did I do? I found it out using an independent subquery. I have that answer, and whenever I want to show it, I just stick that value. Because I mean, maximum salary is only a value, so I found that out, and in every record I just stick it. And but the other thing still goes on. I say the contact ID is in this table, and the salary is equal to the maximum salary. So I do a little bit of cheating. The only thing is now I can show the salary. And just so that you know, it's kind of a little odd, but you could actually take this. So I'm going to do this. It will work. It's very odd, but it will work. I'll take this select statement from here, right from here. It's not as efficient because it will do that job number of times. And I'll kind of stick it. You can actually write a subquery as a field like this. This is also an example of a subquery. So what do? I can't, because I know the maximum salary is everybody's salary, I can stick it right here. And this is a subquery for your information. The rest I can just copy from here. And again, replace this max salary by that select statement again. Oh, no. With this select statement again. Now this is a pure subquery. When I said I can't show the salary, I've now done it using a subquery. So if you have a select statement in your field list, it is a subquery. And so one such question you will find in your assignment also. So this is a pure subquery now. But I'm still kind of cheating a little in the sense, I just try to find the maximum every time, and it is not as efficient because when every time I pick up a record from table my contacts, I for every record I pick up, I also call these select maximum. So as many times as the records will be picked up, it will kind of pick it up. And this one was better because I found it only once and I just stuck it in. I just like copy and paste. So, but it is the same thing, but this is less efficient because this is doing the job once and then you just copy paste. You're just filling the gap. Here, this statement is done every time this becomes true. So if there are 5 people or 10, like in our case, I think there are 2. So every time, so it will be done twice. Now it's not a bad thing because it's only 2, but suppose 10 people were running the maximum, then it will be done 10 times. So select max will be done 10 times. Not only 10, 20 times actually. 10 for here and 10 for here. Whereas this is only doing it once. And then we are okay. So of course that is more efficient. So it is a workaround. It's a little bit of cheating, but it's not wrong. It's right. It's perfectly fine. The last one is very inefficient. So this is pure subquery, but very inefficient. Definitely inefficient. Think about it yourself. Every time I have to call select max. And then every time I also have to, whenever I put something in the list, I do it. So it is definitely less efficient, but it will work. It will work. There it is. It will work. Select max. See, it's looking untidy. But anyway, we'll replace that. Same answer. Same. Who's that now? Oh, we were not able to show the salary in one of them. Then it's salary again. I think we have gone beyond that. So when I said here that I can't show the salary, I wasn't able to. There is no other way. I couldn't. But now I can. And notice how untidy it was looking. So I'm going to give it a heading. Salary. $sign. And close it. And copy this also. Because this is, what was this one doing? Is it showing a constant? I don't know what heading will it show. I think it will just show add max or something. I don't know what it will show. But it looks like it will be untidy. Yep, it will show add max salary, which is again untidy. So give it a heading. Now we'll be fine. Now we'll be okay. So the answers are right. The display names were very untidy. All you have to do is give an as. Okay. Bear with me. It's just doing it. Okay. List the names of all employees with a salary greater than the average salary. So these are kind of using your advanced select statements and joins and subqueries so that you are aware that I can combine anything with anything. So I want an average salary first. So average salary is not a big thing. Let's do it. Select. Remember the function? Average of the salaries from the job current table. Oh, the names of employees. And it says show the average, the salary. Oh, show the salary and the average salary. Okay, no big deal. We just have to think about it. That's all. Okay, so I get the average salary. That's how. Now I want to show the names. The names of all employees with the salary greater than the average salary. And I also want to show what is their salary. Okay, so one by one, the names are coming from the, so let's copy that at least. Right, and I want their maybe I should break it up in two parts, only one, and then show you how I can do the other. If I'm only interested in the names, just list the names, then it's not so difficult. Okay, so from which table? From the table. Okay, so the names of those people. Oh, I'll have to do a join. You can use an inner join. I'm trying to be a little more efficient. Left hand side. I'm trying to find out from the current table. I'm doing a left outer join with my contacts using the contact ID. Why do I need this? Because these are people whose salary I want to compare. Just the names this will do. Again, you don't have to put this in caps. I've been following that convention, so I'm sticking to it. You don't have to there. So these people, these are names of people who have a salary greater than the average salary. I don't know what the average salary is, but we can kind of check this. What is the average salary? Okay, so anybody greater than 91,875 should show up. We definitely know there are people. There were two with 120K. I think I saw one with 110K for sure. So this is 91,875. Anything greater than 91,875. This is the average salary. So anybody who has salary greater than this, let's try who has it. So there are three people with more than. So I think the two 120 ones and the 110 ones. I'm assuming, I can double check. Greater than 98,000. These are job desired. So greater than 91,875. I see only three of them. Do you notice? Only three of them. So the answer is right. But I don't know what their salary is. I have no clue. All I said was show me their names, and you did that, and that was perfectly fine. But if I want to show the salary and the average salary, then of course there is a little more work to do. So all I'll do is I'll kind of copy this. I want to show what their salary is, which is not so tough. I'll say a comma, and I'll say table job current salary. There. And now how do I show the average salary? Same thing that I've done before. I can make it untidy, or I can make it tidy by putting it in a separate select statement. I'll kind of put it in a different line so that you can see it. Same trick. I've just kind of used. So I can get the name from my contacts. I can get the salary from table job current, and I can get the average salary from this table. I haven't used alias names here, but if you don't use alias names, you can just qualify by the full name. I didn't even need to qualify it actually, because salary doesn't belong anywhere else. I needn't even qualify it. There is no ambiguity here. And this will work. Now I'll be able to see who. So Leo, Jamie, and Angelina. Okay, now let's see. There it is. I'm showing their salary, and now it proves that these salaries are greater than 91,875. Can you make this neat? Do you remember? We just round them. We can round them or we can truncate them. So we can round them if you want. So where is that function of rounding? If you remember, it was called round. We can do a cast also and round till 2 places of decimal. There, round till 2 places of decimal. Just because it's looking untidy, but the answer will not change. So you can use the round function and it will show you only 2 places. Now the only thing is this information that the average salary is 91,875 is being repeated in every record. Some people don't prefer to see, but I'm just showing you that you can do it this way. You may only show that value once by doing a single select statement. Oh. And again, you could have, instead of kind of writing it here, remember we could have always used, you could have used your set statement like we did and done it that way also. Nothing stops you. You can do the set. Can use the set too, like we did in the above one. Which of course I'm telling you is much neater. So all you have to do is this. You can say set, declare a variable called average salary. Write your select statement in it and then use it everywhere. Both are correct. There's nothing wrong. Whatever you find easy to do. I mean, it's up to you. Of course, this is more efficient. I'll leave it there and all you have to do is wherever you see these select statements, you all have to do is replace it by the average. It's not a big deal, maybe. Like it was just a little, same kind of cheating that I did there. You can take that variable and you can just remove it, put it here. And it is neat. I mean, definitely it is neater. And more efficient. There it is. You can do it this way. So I'll kind of, now I've done it for you. I just copied it and did a set. But the aim is you can have a select statement in the list of the values. Right in the field list, I can have a select statement. And that is an example of a pure, no, not a pure subquery because it has a left outer join. So if you need to, if the question says, and I think in the assignment I did one of it, I said, I want you to use only a subquery. Please keep in mind that you can do a select right in the field list and it remains a subquery. Okay. List everyone who lives in the same zip code as the person with the highest current salary. So I'm saying, oh, if I earn the highest, anybody who lives in Barrie, I want their names in the same area like me. So we're kind of saying, oh, if she lives in Barrie and she's earning the highest, the job opportunities in Barrie are good. Kind of. That's what the subquery is. So how do we do it? Everyone who lives in the same zip code as the person with the current highest salary. So one by one, find out the highest salary first. What is the highest salary? So the highest salary is select max of salary from the current table. One job done. This is the maximum salary. Now, who earns it and their zip codes? Right? So who earns it and their zip codes? So let's do one by one. Who earns it and their zip codes? Select the contact ID of every person whose, there could be 2, and there are 2 for your information. Oops. Okay, so who earns it? So I'm going to find out everybody whose salary is equal to this salary. And as you put more select statements, start putting them in, you have to ultimately put them in brackets and end them with brackets. And where the salary is equal to. Again, I'm not using in because there is only a single value. Now I want to find out the zip of these people. Where do they live? both ways, but I can't use an equal here because there were more than one people with the same maximum salary. So put a note. Please notice in since more than one person can earn the maximum. So these are the zips for those people who earn the maximum. And now I want to know everybody who lives in the same zip, right? So I don't know what, maybe their name or nothing is given. So I'll just say a select star. It just says list everyone. So select star from the table, my contacts, where they live in the same zip. For a minute, let me think. Now these were more than one people. So more than one zips can come up. More than one zips can come up. There. And that should do the trick. So everybody who lives in the same zips as the people who are earning the maximum. So find the maximum, find people who earn the maximum, find their zips, where do they live, and then find all other people who live in the same zip. So one step at a time. And so there were two people. So again, you can do it this way. See, it's so easy. This, we found out the maximum. We already know the maximum is 1200. Oh, sorry, 120K. Now, who lives in this zips? So to be careful of picking up the right one. Remember 5 and 8. Now, what are their zips? I don't know where do they live, but let's see what are their zips. So two people, 5 and 8. It could be, they could be living in the same area. No, they're living in different areas. And now everybody who lives in these areas, 55, 467 and 77. So 55 and 77. There should be nothing else. 55 and 77. There should be nothing else. So one step at a time. And the best thing about subqueries, you can kind of check them one at a time. So find the maximum, find people who earn the maximum, their contact IDs, find where they live, and find all other people who live in the same area. Try replacing in with equal, and it will come up with an error. So you'll say, oh, that means it is always safe to use in. Kind of. Because equal can be replaced by in, and I cannot make a mistake there. But don't do a hit and trial stuff. Think about it, and then use the right one. So more than one people can have the maximum. So I said use an in here. If there are more than one people, they could be living in different areas. So use an in here. Now here equal was kind of so obvious because max is a single value. So when you compare with a single value, use a equal. You have to think, and think. And that's what the whole thing is about. Okay, let's do the last one and then I'll, 7, 8, sure. You'll have to wait till Monday, that means to finish off the assignment. Name and email of all contacts who currently do not have a job. So these people do not have a job. Okay, so look at the table. So people here, but not here, don't have a job. Right? So people who are here and not here don't have a job. So let's do one at a time. So let's find out people who do not have a job. That's what it says. Name and email of all contacts who currently do not have a job. Okay, so that's select the name and email. So let's do the concat again. That's the name. And the email. I think the field was called email. You can kind of leave it like that. It's not bad. Of all those people who don't have a job. So now, which is my major table? I have to kind of look at everybody. Do you have a job? You don't have a job. Do you have a job? You don't have. You can do it this way. You'll say, I'll go to the smaller table, and everybody who has a job, I can look from that way also and say, oh, you have, but I want people who do not have a job. I'm not saying people who have a job. So in the job current, I don't know who is the extra people who don't have a job. So in this case, my major table is the contacts table. Because job current says who has a job, but I'm interested in who does not have a job. So I'll have to take my major table as my contacts table. When I say major table, when I put it on the left, I'll have to use a left outer join. Join it with the job current table. And just so that I can show you what is the result, I'm going to put a star here. I've always said it's always a good idea to kind of, with outer joins at least, that's how I learned. That's why I'm giving you what I know. And on what are you combining them? On the contact ID. So you can say using, okay? Oh, let's see if using is allowed in outer joins. I know it's allowed in inner joins. Okay, it is allowed. If I don't see a syntax error, I'm hoping it is allowed. Let's first find this result. So I'm trying to do a left outer join. In this case, my major table is my contacts. It's the bigger table, but I want to find out people who don't have a job. So let's do this first. And then I'll say which ones do I want to pick up. Everybody who doesn't find a partner. So anybody who doesn't find a partner is the people that do not have a job. So what condition should I be adding here? So using this, but now where? Which ones do you want to pick up? These ones with null. So you can say where title is null, right? They don't have a job. Not equal to is null. So where the title is null, is there any ambiguity? No, there is no ambiguity. So you don't have to qualify it. You could if you like, but you don't have to. But you're saying where the title is null. So these people don't have a job. And that's what I want as an answer. And then I only am interested in their names. So always start with the star. And then if you're only interested in their names, here. And their emails. There it is. So whenever you find a question like, oh, it's here and it is not here, outer join is what will help you. I'll complete this and then I'll let you go. Sorry, I'll just complete this. Oh, correlated is something, 148. Okay, not too bad. Okay, so people who have a job. People who have a job. This should not be a difficult one. Okay, people who have a job, right? I want people who don't have a job. So these people don't have a job. All I did was use not in. These people don't have a job. So if there is an in, there is a not in, right? You've done this before. You've done in and so there is an in and this. So these people don't have a job. So you should have the same answer. Renee and John. Now the correlated query is a little, it's not tough. It's just a little different way of thinking. It uses the words exist and not exist and work with it. So I'm going to write it for you, but I'll definitely, if it can make sense, it will help you in one of your assignments. If not, we will definitely discuss it again. We'll definitely discuss it again. Because this is a different one altogether. You haven't seen it before at all. There is an exist and there is a not exist. Bear with me, I'm just going to put it so that you have it. And there are, I'm sure there is one on, oh, we'll have to qualify it. We'll have to qualify it. Because when I use contact ID, I mean, they're in two tables. I'll stop here. This one is a little, if you want to wait for 5 minutes, I can explain, but if it doesn't work, I can explain it again next week. This is called a correlated query because of the reason that this outer table, which is outside, is being used inside another subquery. Till now, I said subqueries were independent, and they were. I was doing it. But now this is a query which is not, it is a subquery because you see a select inside it, a select inside a select, but it is called a correlated subquery because there is a relationship. The inner condition is using a field of the outer table. Therefore, it's called correlated, right? And the exists, where not exists and where exists are two verbs. So you have seen a new verb today, exists and not exists, which simply kind of, you can kind of think of it this way, where this exists or this does not exist. Like normal English words, exists and doesn't exist. So what it is trying to do is it's trying to find out the name and emails of all those persons such that they do not exist in the inner subquery. So you're saying if it does not exist in the inner subquery, and what is the inner subquery? The contact IDs are same. So you're trying to say this. Find people who have the same contact ID. They are in master also and they are in job current also. So they are in my contacts also and they are in job current. So you have that list. And now give me the name and IDs and emails of those persons that do not exist in that inner list. That's what it means. It's not tough, but it's something that you have to wrap around your head. So the inner query is using a field of the outer, and you cannot run it independently. You cannot because you're using mc.contactID. So therefore it is called correlated. So what are you trying to say? You're trying to say, give me a list of, or give me a table where the contact IDs match, right? And then now give me the names and emails of all those contacts that do not exist in that table. So who will you get? People who don't have a job. Because what's the inner table? The inner table is joining the two tables on equality. So means people have a job. Contact ID from job current is being attached with contact ID, people who have a job. And you have a table there. If what I'm looking for does not exist in that table, that person doesn't have a job. That's what it means, right? So it says, give me the name and the email of those contacts that don't have a job, where they do not exist in this inner table. So if I do this, so everybody who doesn't have a job, which is again Renee and John, should come up. So I'll stop here. Thank you so much for your patience. I'll stop here. This will kind of help you. If it doesn't, we'll come back to it again next week. But your assignment exists in one of the questions. And anything that I posted for today, I couldn't do it, but that's okay. I still have Monday, so I'm good. I was hoping I could do it, but I'll complete this next week and I'll do the extra ones. Or maybe, you know what, I'll kind of complete it and bring them to you next week. That way we'll save some typing. Okay, I'll complete this and put it. I'll put this on Blackboard for you. So this is going under weekly learning in today's date, in March 2nd date, okay? There is where I've put it. Yes. Give me 1 minute so that I don't forget. Classwork and open and submit. Yes.
For the assignment, question 13.
12 you haven't done because
Yeah,
I think
I
it's a
haven't
self-join. Is it? No, it's not. No.
That one.
So all you have to do is you have to replace the word in by is equal to any. This question. So let me look at the question. Okay. Find the description of each part included in order number 2160. So you found out the 21 part numbers, and then here replace the word equal to. You can, I mean, all it's saying is you can replace the word in by is equal to any.
Okay.
That's just so that when you see it in the exam.
Have a good one, Andre.
All right, Ishmael.
Take care.
This one, I was a bit concerned about number 11 because it seems to get kind of.
Find the order number and order date for each order that includes a part located in warehouse 3. Okay, so the first thing we'll have to do is find out what is this question 11. So subquery, right?
No, well,
Yeah. Okay, so you're using where exists, therefore it is more complicated. Try it using subquery and it will be easier,
okay.
right? Because first find out what parts are located in warehouse 3 and then from there go one step ahead. I think because you started doing exists, you kind of stuck on it.
Yeah.
But it is much easier using subquery. Try it, okay?
Okay, and then there was.
The where exists and where not exists are the toughest things to do.
Oh,
Okay.
I mean, they work.
Yeah, they
think
work,
it's
but
just
you have to
a
think a
bit
little
much
more,
coding.
yeah. And you'll find that they are more coding and understanding.
Okay.
Okay. 15.
15, yes. This. Is this also considered subquery?
We just talked about it, right? So you did a max balance and you used a select and then you replaced it. Where did you put it?
I did it 3 different ways.
Can I see the question? Find the customer number, name, current balance, and rep number of each customer whose balance exceeds the maximum balance of all customers represented by sale. It says give 2 solutions for this query, one using the max function and the other using the all operator,
Right.
which is solution number 2 maybe.
1, which is the max. This one.
Okay.
And then 2 was all.
Okay. Yeah. Okay. So
But I
now,
also came. So
okay,
this
you are
one,
also
so-
doing a third one. Okay. So let's see. So you can do a selection where you can say this, and then you can say,
max balance here. Right here.
can I see the question again? What did it say? Was it greater than? Yep, you can do it this way also.
Okay.
Yep, you can do it.
And for the last question, you just want this one. So
So the any operator and the using the min function and the many operator. So you're okay. Now I don't think we'll need so much. Okay, so what are we saying? The customer number, name, balance, and rep number of each customer whose balance is greater than the balance of at least one customer of sales rep 5. So if it's greater than the balance of at least one customer, yeah, I've given you a hint. Whereas I said, so I've said if it is, you're saying it is greater than any, what you want to do is it's great. If it is greater than the minimum, then it is greater than all of them.
which is
Or the other, right? Wait, give me a minute. Find the customer number, name, balance, and rep number. That's not important. Of each customer whose balance is greater than the balance of at least.
which would be any, this one.
If it is greater than any of them,
So this is going to return a list of all the values that are less than.
whose balance is greater than the balance of all of at
Anyone.
least one customer of sales rep.
65.
Okay,
So there are
right.
3,
Okay.
So this should return any once it is less than what is in here. Right?
If it is greater than any,
Mhm.
then does it mean it is? Okay, this one is right. Okay, now the first one is what we are looking at, right?
Mhm.
The minimum function. Okay, so now what it is saying is you find the minimum.
Of the 3 who have 65 as the customer.
No, that's not right. Something is wrong there. Okay, so what are we saying? Find the minimum.
Mhm.
Okay, so find the minimum where the customer is 65. Okay, we get that. Now what?
Display all the other customers.
All the
who
other
have
customers who have.
more than the minimum.
Let me think.
But also, would this include customers
Yeah,
from 65
65.
who have it? Because in order
Exactly,
to get those out of
yeah.
it, I had to take it out.
So this function should not use min and that function should use min. Okay, so I find out what is the minimum. If the customer number, name, current balance, and rep number for each customer whose balance is greater than the balance of at least one customer of sales rep 5, whose balance is greater than. at least one. So you find the minimum. If it is greater than minimum, no, this was not required. I forget now. I have to think. I've done it, of course, but I have to think. My head is not working right now, and I can't show you the solution, right? Whose balance is greater than the balance of at least one. So if this balance is greater than the minimum balance, so you're talking about this extra condition that you had to put in, right?
Yeah, because there are people who have 65
65,
as a rep
yeah.
who have a value that is greater than the minimum.
Looks okay, but I can't remember. Okay,
So
so
this
give
will
me
just eliminate all the people
who are not, yeah.
who have the rep as 65. Because if you leave it as equal, if you take this out, then you are going to get 2 customers from 65 who have the rep as 65 in that list also.
Yeah, let's look. Let's cancel for one second.
I can't remember. I really can't. I can't. It's not. I can't think about it. Sometimes my
So I
head.
think there are three customers from this list. This list is going to return 3 customers.
Right.
Okay, so minimum of the balance
But you only need
whose
one.
customer's rep number is 65.
Right. So you only need one value from this, which means that the other 265 would also be a part of the bigger list.
Whose balance is greater than the balance of at least one customer. Okay, so we find the customers whose customer rep number is 65. We find the minimum of it, right? Okay, we got it. Now we want all those customers' numbers and whatever, whose balance is greater than of the minimum. Now, why do we need this one as
No,
well?
I just put that in there because if you take this out, if I run this,
Yeah. Shouldn't this only work?
you're going to get 2 from the 65, which are the remaining 2, because technically only one person from this list.
Okay, I see what you're saying.
So it is working, but if you don't want to include the 65 group, this is what I had to do. So I'm not sure if it's supposed to include it
or not include it. Okay, find the customer number, name, current balance, and net number for each customer whose balance is greater than the balance of at least one customer of sales rep 65. If I haven't said anything, I know what you mean, that the rep number, whoever will be greater than the minimum. So there is a minimum value. What is the minimum? Just run the inner one. And shouldn't 65 be in quotes? Wasn't it a?
No, I think it's a number.
Oh, I doubt, but anyway, you know better. I haven't looked at it. So this is the minimum. Now I want to look at all those
Did you meet somebody named Tristan Carrot?
numbers, names, balance, and rep number of each customer whose balance is greater than the balance of at least one customer of sales rep 65.
Just wondering.
So all I'm saying is, if your balance is greater than the minimum of these, I want you listed.
So that would include the other 2.
The other
from
2 also,
65.
yeah, that's
Oh,
okay, I think, right? Because I haven't said, oh, you can't belong there.
Yeah, 'cause
I think,
left
yeah.
This one would also show them. I just put it here because.
Oh, because you weren't sure. Okay, okay. Let me look at my solution then. But I think the question is not saying anything, so. From the question, it doesn't seem like, but I can always, okay, so relational database and.
So for the ones that I use exist, I should change this.
No, I don't, I'm not telling you to. I'm just telling you that they're more tough than the others.
Oh, okay.
Yeah,
So
no,
it
you
took a
don't
while
have
to
to.
understand.
If I haven't, yeah, whatever works for you. This is 15.
Yeah. No, that's 16, sorry.
Okay, find the customer number. Yeah, no, if I haven't said it, I haven't done it.
Okay, so I can take
Yeah.
out this part of it. Just leave it to include.
Includes,
65.
yep.
Okay.
Because the question doesn't say anything, right? So I haven't done it. So which makes sense. I haven't asked it, so you don't have to.
Yeah, so I
Yeah, 65 is a character.
can- Okay.
Yeah,
Yeah,
just
to
so
go
that you,
through the-
yeah.
just
I mean,
go
because
through.
I don't want you to lose marks for silly things.
Yeah. So while I'm going over, I just make sure
Yeah.
everything is formatted.
Formatted correctly. Yeah. No, if I haven't asked, then I don't need it.
Okay, I think so.
Okay. And again, the exist is entirely up to you. I mean, I'm not forcing you not to do it, but I'm just telling you that's the most toughest thing to do. Yeah, it will. It will. So I haven't even done it in class. So I wasn't even thinking. So I've only asked one, I think, with exist and not exist, just because I want you to know about it.
Oh, okay.
Yeah, yeah. But the rest, whatever you like.
Okay.
Yeah. I don't find exist and not exist easy. I don't find them easy. I find them much tougher than subqueries, and it's just, or maybe it's just me. I always avoided them. Yeah, you can run them individually, so you can think about them. But if it hits, good. If it doesn't, then
Yeah, I'm gonna get a lot of drawing out on paper first.
first, yeah, and that will help. That will help.
So
Yeah, you're doing
test
well.
on Friday would include this stuff.
Everything that we are doing right now is what will be included.
Okay.
And I'll try. I'm thinking that I can give you the same tables that I gave you in the assignment, so it's not difficult, because understanding the tables also takes some time, right?
Yeah.
So if I keep these tables and create new queries, then at least you've seen the table structure.
Okay.
I think I'm leaning towards that.
Okay.
That way, I'm okay.
Yeah.
Right?
Okay, I'll just have to tidy up then. So our class next Monday will.
We'll continue with this, because exist and not exist is what I want to little bit more to do, and then the other examples are easy. This is the most toughest one to do, because I'm trying to do everything in it, right?
Yeah.
The other ones are easier.
Okay.
And then we'll go from there.
All right. Thanks, man.
Okay, you're most welcome.